Thank you.
Hey, this session is being recorded. You will have a copy of your audio video in your folder, which is automatically synchronizing to your laptops and desktops. I have started recording. So, up until now, we have briefly touched upon infrastructure elements in the cloud, right? We're beginning to go deeper in that segment. So, if you broadly think about infrastructure, it comprises of three broad aspects, like the compute horsepower, right? The storage elements and networking capabilities. So if you think about, who are the manufacturers that provide these components from a compute perspective, it is Intel, AMD. If you think about that, and then you on top you put CPUs and in a motherboard and make a computer and all that good stuff. So that's how the origins are from a compute perspective. From a storage standpoint, you can get storage at least in two different types. One is like a directly connected to the computer. It's like the block storage, as we call it, like block, where you get access. You put your file system on top, and that's in Windows terms your C drive, for example. Other type of storage is your file storage, where you can have a file system remotely connected, accessible to you, where you can put objects. It's also called an object storage, and so we'll discuss some of these and do some exercises in this storage element also. And then from a network connectivity standpoint, broad characteristics such as how much is the bandwidth, how much is the latency, and what the what elements do we have in terms of security, in terms of access control. Those elements come into play when we are dealing with network components. So these three broad things, if you think about, and even we can go deeper in storage and understand, how many IO per second are we getting, and what the total size of the storage is in terms of gigabytes, terabytes, petabytes, whatever we have. So that's the capacity, the performance of storage, and in terms of accessibility, durability, availability, all those in general entities apply in terms of characteristics of storage. And these three things, if you think about broadly, get classified as infrastructure. And if you have these available as a service, then that's the collective name that we use, at least in the context of cloud. Now, if you take that example directly back to one of the cloud providers, I hope you can hear me okay. And if you're not hearing me okay, please let me know.
Loud and clear.
Thank you. So, in the context of Amazon Web Services, if you look at the console, this is one of the most comprehensive and at times daunting dashboard of services. So, you have a collection of services, and we'll go through each and every one of them to understand how do we make use of these things. And this is, as I said, most complex, most daunting, and comprehensive in terms of collection of services available. On the contrary, this one is very, very trivially simple. It's just one service called the infrastructure. Like you get machines, that's it. Nothing much. Whereas this one, the Google Cloud, is somewhere in between. And so it is also comprehensive, but not as variety of services available from Amazon. I think Amazon is the leader in the industry today. That's a given. Now, some people prefer other clouds, and that's okay. Even in fact, I prefer this cloud myself for its simplicity, as I said the last time. So let's go back to Amazon and understand what infrastructure elements are on this screen. If you look carefully, what are we looking at? On the left side, you have the compute section. Right, in this compute section, you have a bunch of different services such as EC2 container service. That is where Docker containers can be run. Elastic Beanstalk, this is their own implementation of running managed applications. Conceptually, this is like a platform if you think about it. And then this new service called Lambda. This is running code without servers. So you have code, you want to run it, you don't want to worry about setting up a server. You use the service Lambda. Basically, you give the code to Lambda, and Lambda will do the thing for you and run the code for you without you having to worry about setting up a server. Whereas in EC2, we are actually creating a server. We did last time, right? We created a virtual server in the cloud. If you scroll down, and you'll find storage and content delivery as a segment, as a complete collection of bunch of services again here, and we'll also go into the details behind these guys. But if you scroll back to our illustration, this element, the storage element, is what we are now looking at here, where we have the scalable storage in the cloud called S3. S3 is an acronym. It stands for Simple Storage Service, S3. S3. And so that's what that thing is. Basically, it's a ridiculously simple storage service. And I'll take us through examples of that also. Next one is, hold on, I think I just clicked by mistake. Let me go back. Next one is CloudFront, which is content delivery network. And we'll talk more and use examples of this in terms of how do we make use of CloudFront to improve performance, and content delivery networks in general to improve performance of applications when you're distributing content globally without breaking the bank. The key is without breaking the bank. For a few cents, you can take your content worldwide, and literally few cents, nothing more. And we'll see examples of how we do that. Then we have Elastic File System. This is in preview, just came out. We'll talk about that briefly, but this is in preview mode, so it may or may not be available to some of us. It selectively is given out to people. Not everybody gets everything at the same time unless the preview is finalized. Next one, we have Glacier. This is like cold storage, as in, you store stuff for the long term, archival, it's there. And this is conceptually what I call not online, but nearline storage. The word I will use is nearline. It is not really online, well, almost online, but the word I would prefer to use is nearline storage. It's almost online. So think about it that way. That's what this thing called Glacier is, and we'll go through examples of that also. Back in our screen here, we have Redshift, which is like a data warehouse, and DMS, database migration services. So this is for migration of database from A to B. If you want, use that service. Then the third thing, which is about networking, which is where the third segment comes along, network. And that is relating to bandwidth latency, security, access control, VPC, and VPN, and special connectivity. And so all those aspects are clubbed together in the networking section, where you have a place to create VPCs, manage them. And you also have this thing called Direct Connect. This is like a direct pipe from your office to their office. And so you can establish that through a variety of different providers, and we'll go through that also. And then Route 53, this is like the post office of the internet. Post office, as in literally the post office. Route 53 is actually a play on the word port 53, which is for dynamic domain name service. And so that's where they have named the product Route 53, which is basically a DNS service. And it is the post office, as in, I will give you a quick example. How many of you know the place called 1600 Pennsylvania Avenue? Do you know what this thing is?
Yes, that's the White House. Everybody.
Yes, it's the White House, right? So that is a friendly name. And this is the IP address. Think of it that way, right? This is like the whitehouse.gov. Don't go to whitehouse.com, whitehouse.gov. So that's the friendly name, and this is the IP address. Think about it that way. So that's what DNS does, for CNN.com. There is this IP address, whatever we have, and that mapping is made possible through the Dynamic Domain Name Service, DNS, or Route 53, or other related services. There is an open source product called BIND. That is what is used in creating this service, Bind. Bind is a internet. Bind is this. This Bind is a open source product. It is the most widely used name server. You probably have it running on your phone or some other Linux machine, or some other Android phones. You might have it already. If you're using Macintosh, you have it already. So this is like the standard on the internet on maintaining domain name systems, and that open source product is what is used in this thing called Route 53. So that was a quick overview of these elements. Now we'll go deeper. We discussed briefly about these things, right? Called compute, storage, and network. Now let's go exhaustive in terms of traversing the tree down. There is a question from Michael Curry. Hey Michael, it will be nice if you can post the question in Slack chat, because I tend to miss on the GoToMeeting chat. But go ahead, your question,
Oh
please.
yeah, yeah, no worries. I was just gonna ask about the elastic storage. Was that similar to what you were talking about when we were going over virtual machines, where you could go from 2 megs to 2 terabytes, and it would grow as your um, as your storage needs increased?
Conceptually,
It
yes.
was
Conceptually, yes.
okay.
Except the word was dynamically allocated storage, and this is elastic storage. Concept is similar, but the idea is different, right? This one,
Okay.
elastic file system, is actually a
Uh-huh.
file system for EC2, meaning you get this is basically a grid file system. If you think about multiple computers, what you are getting is creating a file system shared by multiple machines. That is what is possible through this EFS. This is preview right now, but if you have a bunch of machines like EC2 machines, for example, and you need a common file system for that, that new product, this one, preview, Elastic File System, is a fully managed file system for EC2. So you can get file system for these guys external. What does that mean? You have, let's say a machine number v1, v2, v3. Each one of them has a disk that is local. This is the Elastic Block Storage Disk, EBS disk, like we have had an 8 GB before, if you remember. And so that disk we created along with a machine. So if you want an extra file system available for all these machines, external, that is what this Elastic File System is, EFS. That is going to give you access to a common file system for all your virtual machines inside EC2. And so it is beyond, and in addition to the local disk, you have the EBS volume, which you probably remember and recall from here, right? When you start a machine, you launch an instance, and at some point it will say, you know what, get some storage. So there we have this 8 GB of storage. That's a disk, right? This 8 GB of
Yep.
jump up was SSD. That's what you're looking at here, right here. But then if
So
you
that
want,
so that would be like a NAS, JBOD, something like that.
yeah, this will be more like a grid FS. So it's a shared file system among these PCs, these machines. And so a network attached storage is conceptually very similar, except this can be it will also allow you locking of files and writing in terms of permissions, and also be useful to run things like high performance computing. There is a need to run need to get a low latency file system for these machines. For example, I think we in our group there is at least one person who is a HPC expert, so he can tell us more about these things. But the idea is, if you have a high performance computing requirement, you need to have a low latency connection between machines and also have access to a shared file system. And that's a scenario where the EFS can come into play. It's conceptually similar to a NAS, except this is a higher performing low latency connectivity. That option is available to us in this example here. Back to this location. So the elastic file
I
system.
assume that's also expensive because of the low latency, right?
Yes, it is somewhat a little bit more expensive. Let's see the pricing, and you have to have a VPC defined and then figure out the pricing. So there should be a pricing option somewhere. We can find out the pricing later. But let's keep digging through each of these, at least the compute, storage, and network elements as we go along. So the last time, if you remember, you had this EC2 and you started a new machine and you click through. And maybe I can rush through the clicking of buttons a little bit faster because I am assuming you know this already. So if I'm rushing, just pause me. But I want to go ahead and actually quickly create another machine right now. And so that's what I'm doing. There we there we have. And enabling access to a machine. I'm just quickly starting a cheapo machine, calling it testing 123, and configuring security group details like this, and launching it quickly. And so here we have to launch this, and I'm going to acknowledge that I have the ID RSA key pair, and I launch the instance, and that's what I just did. So I have launched a new instance. What does that boil down to is that I'm now able to connect to it from my terminal, right? Like this. I should be able to use my ID RSA, the private key that I have here, this private key. Oops. Hold on. Yeah, this private key that I have, and I have already given the public key to Amazon, so I should be able to connect to that machine right now. Now, when I do that, there are a couple of things. These are security implications that I would like you to be aware of, and that is what I'm trying to illustrate, is that this new file that you may have seen got created called known host. That is something that I would like you to understand what that means and why it is relevant and why it is important. This is a spoofing prevention measure. It prevents accidentally connecting to wrong machines and prevents unauthorized access in some fashion. I'll tell you and show you how to understand that. So if you remember, on this machine that I had in the last time attempted to connect to two different computers the last time we met. And so that known host file contains entries corresponding to those two machines. Let's see them, known host. And so here we have one entry corresponding to the machine that I created first, and then the other line below that. These two entries are created automatically based on a hash of the machine that we connected to, and these entries are now available as a listing called the known host, right? Sorry. The known host. These hosts I know, I trust, so I can connect. However,
and they could be from multiple vendors, correct? You could have one from DigitalOcean, one from Amazon, or
yes, yeah. All of our discussion that we do in the program is vendor agnostic. All.
Right. So that file can contain multiple vendors. Okay.
Yes. Correct. All of my discussion is vendor agnostic. Except if that is not the case, then I will tell you that this is company specific. But most of my discussion, almost everything that I do, has nothing to do with any one company. It has to do everything with the technology itself. So the idea essentially is, in our example here, we have connected to two different computers, which is one of them is this one, and the other one is this one that is listed out in the known host file. If you remember, these known hosts are known to me now, but I just started a new machine and I don't know that one yet. So I will go to my, hold on. Yeah, I'll go to my Safari browser. There we go. And I have this running instance apparently, this testing 123 that just started, and with this IP address. So I'm going to grab the IP address, copy, and then go back to my workstation here. Now here, if I try to connect to that machine, like SSH, and then Ubuntu at IP address. Come on, IP address. Not copied. Okay, copy again. Copy. And then please allow me to paste. Thank you. No, it doesn't want me to paste. Fine. We'll do a side by side of these guys and get it to work. So I can see them visually and put it side by side. So doing that right now.
You hit Control Shift.
Yeah, I don't know why, but my copy and paste is not working for some reason, only known to the computer guard.
If you click on the left mouse button, it'll also show you a paste option.
Correct, except it did not. So
Oh well, unless it doesn't.
yeah, see, it is
Oh darn it.
yeah.
Yeah.
So no worries, no worries. So what I was trying to illustrate was this point that okay, my mouse, please talk to me. Uh, there we have it now, somewhat in place. And so I'm going to now take that IP address and manually type it over. I hope I can see. No, no, no. Okay, I'll figure out some other method. I'll put this on a different monitor. How about that? That's a good one. So I have put that in the different monitor where I can just read the IP address. And now I'm going to begin typing it 52.10.35.121. Now, when I do that, you will see that I need to also pass my private key, which is the ID RSA. And now very carefully read the response I'm getting back from the computer. So it says the authenticity of host 52.10.35.121. This guy, new machine, right? This new machine, I don't know what you're doing. I don't know what you're connecting to. Are you sure what you're doing? That's the question it is asking me. It is telling me, I don't know this machine, man. Are you sure you want to connect to this thing? That's the question. And if you say yes, you know what will happen. It'll allow. If you say no, it'll reject. Let's say no. It says verification failed. You're not sure what you're doing, so I'm not letting you connect to it. That's the response, right? Now, if you go and examine our known host file, it doesn't have the entry corresponding to this new computer that I just attempted to connect because I said, no, I don't know what I'm doing, right? This time I will say, yes, I know what I'm doing. So I'm going to enter again and the same question will pop up. Boom. The authenticity of host blah cannot be established. The fingerprint is this thing. Are you sure you want to connect? And if I say yes, what will happen is that a new entry will populate inside the known host file saying, I now know this host. So I can trust it. So if I say yes, it gets added in the known host file. It just said that right there. It says, I have permanently added that entry to the known host file. Okay, then thank you. But then I'm going to come out of it and I'm going to clear my screen and I'm going to see my known host files. And I have a third entry now. This third entry corresponds to the machine I just connected to and said, yes, I know it. I know what I'm doing. And so that is a line added to the list of files or list of entries in the known host file. On your workstation, you have a file called known host, which contains a list of hosts that you know already. Great. So that's the concept of this known host file. Now, if you try to connect to that machine one more time, it will silently connect without asking you this prompt question. Are you sure? No such question. It just connects. You see that? No question this time. And that is because we know the host. And that's the idea that you have, is to create a list of all the hosts that you know and trust so that users who connect to machines don't get prompted to again and again, and it silently logs in.
So
Similar-
Nilesh, I have a question. So in saying that you never share your private key ever with the other side, by handing over your private key to them, you're not really handing it over. You're just sending it over so that your source side, where you're starting from here, from the Linux side, it is doing the checking of the far side, the Amazon Web Services side. So you're not literally handing your private key over to them. You're just using it as a key to unlock their lock with the public key, so to speak.
Correct.
So you're not literally surrendering your private key to them. You're just using it as a key, but they never actually see what that is.
Correct.
And then you're absorbing it into, okay.
Yeah, this line, when you are passing the key, you're passing it to the SSH command. You're not giving it to the other company.
It's still encrypted. Okay, you're just right. Okay.
Yeah, you're just passing a reference to this command, SSH. Hey, I have the key right here. There we go. That's my private key. It doesn't actually go to the other end. it says here only for decryption and mapping with the public key and connecting to that remote computer, which happens to be this IP address 5210, whatever that IP address is. And so we just saw this connectivity established and a trust relationship established in a file called known host. Similar to that, we have to have a understanding of what the other guy is doing, what the other machine is doing. This 5210 35 121, there has to be something corresponding to, just like known host on the workstation, there has to be on the other side another file that keeps track of known users, right? Just like known host, known users. There has to be something like that, which is known underscore users. But the actual word or the language used is not users, but authorized keys. Which keys are authorized to access this machine? That is the file created and stored on the remote machine. Let's go examine. We are already on the remote computer right now here. This is a remote machine. We are connected to it, and I have a prompt from that remote computer right here. So now if you go and examine on the remote computer in the folder .ssh, what do we see? We should see this thing. Let's compare cat.ssh and cd.ssh, and then list out. What do we have? We have a file called authorized keys. Now let us examine its content. What do we have in that file? Cat authorized keys. And what do we see? We see something that looks like a public key. And by the way, this is exactly our public key. Let us find out. Another terminal on the other side. Open up our public key and match it. Item by item, it matches, except the comment. From here all the way up to this point, it matches. And it matches because that's what Amazon did, is put the public key in the right location inside that remote computer in this file called authorized keys. These keys are authorized to access this computer. Other keys are not, obviously. And this is analogous, very, very similar to the idea that we have here, which is known hosts. I know and trust these hosts. You can connect to them. And on the flip side, on the remote computer, these keys are authorized. I know these keys, and you can allow these key holders to connect. And that's the idea behind us giving our hold on. That's the idea behind us passing along our public key and pasting it in the key pair section right there. That is the idea. So this key that we posted, I gave our public key. Amazon took that and placed it inside this file here, authorized keys. And that key is placed by that reference inside the file. And here we have ID RSA. Now, let me show you a crazy example. What I am looking for is a volunteer who can give me your public key. Public key only, not private. A volunteer to give me your public key, and what I will do is I'll manually add that public key in the authorized keys file right here on this computer right now. So please paste a public key. Any one, the first one I'll take. So paste your public key, and what I will do is literally edit this file, authorized keys, on the remote computer, and VI authorized keys. So I'm ready to add your public key to this listing, and I'm looking for a volunteer. There we have Alex. So Alex has given us a public key, and so what I'm going to do is grab that and SSH DSS. So, okay, you have taken a ID DSA key, which is cool. There is a different type of key that Alex has decided to create, which is totally fine. And the key that I created was RSA. His key is a DSA key. And we'll see the difference momentarily as soon as I'm ready to paste. I hope pasting will work. Pasting may not work. Oh, that will hurt. That will really hurt. But, okay, bad idea. Just bad idea. How do I copy this? This is crazy.
Is Command C not working for you on your Mac, or maybe it's...
I know what's going on. What is going on is my guest additions are not set properly. And so I will show you how to fix that situation. What you need to be able to do in this scenario is that go to machine and then devices, insert guest additions, and this should work. As soon as this setup finishes, I'll go to run the guest additions software and put my Cloud Genius password, which is Cloud Genius, authenticate and let it run. This basically enables bidirectional copy and pasting and some niceties in terms of display controls. This is basically adding device drivers onto this Linux box to make it work with my physical hardware. And that
you could share the clipboard.
Yeah, share clipboard, share mouse movements, all that thing, all the niceties come along with this guest additions. And that is what I'm doing right now, is building the driver set into the machine and putting that in the workstation. So I think it just finished, which means I hope my copy and paste will work after a reboot. Let us see whether it works right now. So here we have SSH. Copy from the key and bring it here. Okay, let us paste. No, not yet. So let's quickly reboot. And I am rebooting only my workstation, which should be quick. And so I'll be back. But the concept I'm illustrating is that once we put the public key from Alex into the remote computer, then Alex can also connect to that same computer because his key gets authorized. However, there's one more thing, which is security groups. And in my security group, my rules inbound are very narrowly focused. And can you tell me why, even if I add Alex's public key, that it will still not allow Alex to connect? Can you tell me why? The answer is right below my mouse. Can you tell me why?
You're only allowing access. You're only allowing access from your from your IP.
Bingo. So I need to actually expand this and add a rule and get SSH to be allowed from a custom IP, and this is Alex IP. Alex IP :32. So that's what I will need to add as soon as, and so Alex's IP address is coming up, which I will be able to copy like that. And let us see, like this. /32, and that is an IP address I just added. So now we have two entries. One is this, and the other one is this. Both look Comcastic, apparently. Comcastic as in the company. And so now we have enabled routing from Alex's IP address, which is one step. Let us do the other step, which is here. And this is running. And I hope the copy and paste works. I hope. Let us see, copy from some random thing and paste in here, and it won't. Great. So copy paste now works. Beautiful. So I'm going to connect to that remote computer. And in here, I'm going to look at my .ssh folder, and I have my authorized keys file. I will edit that file, and in that file, create a new entry and paste the public key that our friend Alex has provided us. Copy, and watch this. Paste word. Okay, so great. So we have copied and pasted the other key. I'm going to quit. Now in my authorized keys file, I have 2 entries, which means both Nilesh and Alex can connect to my computer. Now, how does Alex connect to it? Let us figure out. We'd like to request Alex to run a command very similar to this one, except Alex will
I'm
need
in.
to, yeah. Oh, Alex already connected. There we go. So now we can check whether Alex is already connected by typing who. And we have 2 connections, right? We have one connection from this, I think one of them is Nilesh and the other one is Alex. I don't know which one is which, but you get the point, right? So we got 2 people connected to same machine, and we did a couple of things. And those things were, let us recap. What did we do? So back here. We played some very crude way of dealing with directly go our nuts and bolts inside a machine and paste and copy and hack and all that. So we did that. This is what Amazon does. This is what Google will do. Exactly what we just did. That's what they do all the time. When you start a machine, let's call it machine number V1, VM number 1, and you have your keys. The keys are provided by you in this location, key pair, right? This one, this key ID RSA. So you gave the ID RSA.pub, and that key was given to Amazon. They have put this key inside this computer in a folder called .ssh, authorized keys. And in that file, they have this key, public. The public key pasted right there in this file. And that's an indicator that anybody who has the corresponding private key can connect. These keys are authorized keys. Similarly, the other side, the other perspective to this. On your workstation, you have this .ssh folder. Inside, when you first time connect, there is a new entry created in the file called known_hosts, plural. It is plural. Similarly, this authorized keys is also plural. It can be more than one, like you saw. And so hosts, it can have a number of hosts that are okay to connect to. You can connect to these hosts without additional prompt or warning. It'll let you connect because you know and trust these hosts. You can see these examples in our case here. I'm going to open a new terminal and new terminal and go to my SSH folder and copy the cat, the known host file, and I have 3 entries, 1, 2, and 3. The first 2 are the entries from the last attempt, and those 2 machines are dead. We killed them last time. This third machine is active. So my known host file is kind of cluttered. I want to clean it up. How do I clean up? Known host and delete. I just deleted 2 lines. And now my known host file is a clean 1-line entry corresponding to this computer here. And so that's the idea behind known host, this one. And you can have as many entries as you want to connect to, as long as you know what you're doing and you are okay to connect. Similarly, these authorized keys are a listing of all the keys, the public keys, public, not private, all the public keys that are okay to connect. So you can come in. So what we just did in the example is that in my remote machine, in that folder, there was this file authorized_keys, plural. Amazon put my ID RSA.pub in that file already to begin with when I launched the machine. It already did. And what I did beyond that is pasted one more entry. And this was Alex Ramos public key. And I added that key, appended the key to the list of authorized keys, and then opened up my security group security group is basically a collection of rules. Collection of rules. And these rules are, in my case, 22 from my IP, my IP allow. And so I expanded 22 Alex, Alex IP allow. And then Alex succeeded. Bingo. It was very simple. But that's what's going on when you have any of these providers, DigitalOcean or Compute Engine or God knows who, right? I don't even care who. These people, what they're essentially doing is taking your keys, like this example from DigitalOcean. We gave them a public key the last time here, and it is sitting right here. They have it already. So they'll take that key and inject into the machine when you create one. And when you create a droplet, that's what they're essentially doing is this file. They are creating it, putting it inside that file, putting your public key and allowing a seamless access without having to type a password and using your private key that you already have. Now, having said this part, are there any questions about these two concepts called known underscore hosts and on the other end authorized underscore whatever that thing is? So pardon my typo, authorized underscore keys. Are there any question about these two concepts? This is your local workstation. This is the remote machine.
Yeah, I have a question. This is Ted.
Yeah.
So let's say you sense a compromise, and you have a couple of active, pretty critical servers, virtual servers, whether you have dual factor authentication or not, or whatever, and you're using these authorized keys. Now, silly question. Is it possible to deactivate or swap keys while a server, I mean, the answer is probably no, but I imagine you'd have to stop the server and reactivate it with a new key. You can't swap keys mid-stride, I'm guessing. What's the answer to that?
You can, and I'll demonstrate that live right now. So here, in my remote computer, this is the machine that I am connected, this is the machine that I am connected to and Alex also connected, right? So in this machine, if I think that Nilesh is now the bad guy, I want to kick him out. And so what I will do is edit that location, go to that location and have the authorized keys. I will go and VI authorized keys file. The two keys I have here, the first one is Nilesh key. The second one is Alex Ramos. So I will now label Nilesh as the bad guy, which means I want to block
the key, if you want.
right? Which means I want to block the key completely, which means I will delete that line. And now I have managed to eject Nilesh from accessing this machine. And I will save this file like this, which means next time anybody who attempts to be accessing this computer with the key corresponding to Nilesh, that person will not be allowed. And we can prove that right now. So I have removed my key from the authorized keys file. When the machine is up and running right now, it is live. Alex can still connect, but as soon as I log out, I cannot connect myself. So here we go. Boom, permission denied. Because I am not authorized. My key is not authorized. So I cannot log in. I just shot myself in the foot because that's what I decided, right? So yes, your answer to your question, can you dynamically do it in a live running machine? Absolutely yes, like that.
But now you can't change it because you can't access the machine, right?
Correct, I'm screwed. Yeah, exactly. And so what I can do is ask Alex, hey Alex, can you please put my key back? And then Alex can, if he wants to, allow me to go in. But if not, then I'm screwed. Like totally screwed.
But you can't go in through the Amazon website to that machine instance and add your public key back into that device?
Not possible. Exactly not possible. There is no way in a live machine you can inject a key unless you have access already. Now from here, even though, let me show you, even though the key pair name listed is IDRSA, which is my key, even though it is listed, I still cannot access. And there is no way I can actually access now, even though I can delete the machine like this, terminate, and it will kill the machine. But no, sir, I cannot access myself because there is no way I can inject my my public key into the list of authorized keys. There is no way I can do it except Alex can. The only person who can is Alex. And the reason is because his public key is in the list of authorized keys. So he can go in and manually edit and put my key and then give me access back. Only he can. Nobody else can, not even Amazon. And even if you
But
have
you still
access,
have the ability. I'm sorry, go ahead. You were saying, go ahead, I'm sorry.
yeah, I was saying I still have the ability to terminate the machine. That's it. That's all I can do.
So what good is that if you have the ability to terminate? You still can do malicious damage that way.
Correct.
If you need it to be.
Correct. Because I'm the owner of the account, right? I'm the owner of the account.
Oh, okay.
That's why I can terminate. Otherwise, there is no way I can terminate the machine. If I'm not the account owner, I cannot kill it.
Okay. So if there was some sub-administrators who, I'm trying to think of a situation. Oh, I see. All right. So just because you're the owner, but if there were some sub-administrators whose keys were removed while it was still running, they can't terminate it. They just can't get back in.
Correct. Just because I'm the owner of the account, I still have the ability to kill it.
That makes sense. Okay.
But otherwise, no, I would not. I can do nothing about it.
So here's a question for you. Somebody like, say, at Expedia, somehow or another their authorized keys file becomes compromised.
Mm-hmm.
What would they do? I mean, these guys are enterprise-wide systems. People, thousands and thousands of people hitting the server. How would they fix that?
Doesn't it not matter because all it has is public authorized keys, just has public keys in it, so it shouldn't matter, right?
So,
or are you talking about getting deleted?
Thousands of people aren't hitting their server. They're accessing it via a website.
Well, my point
So they're not logging into the server, right?
Like Nilesh, I'm sorry, I probably misspoke. So Nilesh just went in and took his. So he took his known host or his known keys out, right? How do I explain this? So somehow that file becomes compromised. That's got the authorized keys in it for whatever. Say they got a virus or something like that, and that file becomes compromised. And now the administrators can no longer get back into that server. Well, the website that they run is on that server, right? Does that make better sense now? And so if you have thousands of people accessing this website that's on that server that's been compromised, I'm sure there's some type of backup that runs concurrently with that machine. But what would they do in that situation?
So I think I understood your question, I hope. And so I'm going to elaborate the question in a different language, a different fashion. So here is an example, okay? So the question I think you have is, let us identify some roles here. Role. The roles are system admins and public users, right? Let's see this case of a Sony PlayStation.com or Expedia.com, like the big websites, right? And so there was a case in history where Sony idiots managed to lose the private key. They lost this. And what happened is the private key got accessible to public at large, like anybody could. What does that mean? It means that all the information about users and their addresses and their credit card numbers and all of that was showing up on the Pirate Bay. This has happened, by the way. Audio lost. Is the audio still lost only for Michael, or?
No, we can hear you.
Okay.
I can hear you anyway.
Okay. Sorry, Michael. Please correct through phone line if you can. And so the challenge becomes when you lose your private key. That's where the critical thing is. When you lose a public key, nothing happens. I don't care. Private key is what you keep private, and that's the definition of it. Keep it private. And so, what the question I think what Michael has is, what happens if you have like more than one sysadmin, and one of those sysadmins leaves the company, for example, leaves say Expedia or leaves PlayStation. How do you handle that situation? He's not worried about public at large, because public at large, even though the sysadmin, let's say Expedia.com, Expedia, they have this website, public website. People go and buy tickets there, right? Ticks. And so that keeps on going, and keeps on working, as even if you lose your ID RSA private key, and there are maybe 2 or 3 sysadmins that have access to this private key, and one of them decides to leave the company. Let's say number 2 decides that I want to leave the company. Now he or she has access to the private key. Now that is a problem. It's a security issue that you have the sysadmin who knows the master private key decides to leave the company. Like he's leaving Expedia, bye bye. So now, as a security precaution, what you need to do is what I call key rotation. Key rotation is possible mechanically and automatically also. The simple technique to do is you have this ID underscore RSA key right now, and you have 3 sysadmins, number 1, number 2, number 3, and that's it. It's a small group. Now you have this key and the corresponding pub key already, and the machines are all up and running, and this is in place, and this you have a secret, and these 3 people know. Now every so often, typically every month, it's a good idea to rotate the key. What does that mean? You generate a new key, ID underscore RSA number 1 and ID underscore RSA number 1.pub. It's a different pair, and you use both the pairs. So you put both these entries in the authorized key files. Make sure that the second one you just created also works. And then when the second one is working fine, then you delete this. And you just rotated or changed your key. Then every so often, you will also create another 2, an ID underscore RSA number 2.pub, and another rotation happens every so often. And this rotation has to happen just as a method of sanity. This is like changing underwear every day, taking shower every day. It's a hygiene factor, right? Same idea. You change your key, you rotate them every so often, and especially when a person is leaving the company, you absolutely make sure to rotate the keys and before they go. And so if they are gone, that's okay. They can carry their old private key with them. Nobody cares, because that key has been deauthorized. And we have now moved on to ID underscore RSA number 3 and the corresponding public key. So that's the security measure people have to do, and you never ever manage to lose your private key, and you keep the group small ideally. Or if that is not possible, I cannot imagine why you want to give your private key to like 100 people in a company. There is no reason to. So keep that group very, very small, very, very focused, and make sure that we are in control, and keep the things rotated every so often. That's the way people manage keys, especially sensitive ideas such as the root keys for the master website, for example. I hope audio is back for Michael. And so does that answer your question, or was it your question?
Yes.
Okay, good. So
I was thinking, I thought he was alluding to the idea of if the authorized keys file, let's say it got removed or for some reason, and sysadmins got locked out, it'd be a similar situation where maybe port 22 got shut down by some admin who was inexperienced. But I guess ways to get around that would you just log into the physical machine using maybe ILO if you're using HP hardware or some other mechanism.
Now, the response to that question was access to physical machine is not possible in the context of cloud. Not possible,
Yeah.
right?
So yeah, that's true.
Yeah. So the workaround is to use another method to recreate your machine. And you
Just
can
make a copy.
yeah, copy is one method. Other methods exist. You just quickly regenerate your machine. And in fact, that brings up a good point that I hope you will appreciate. It's a joke. It's a joke being cracked by a person of Indian origin who is supposed to worship cows. Uh, joke apart. But the idea is, if you have a cowboy, and imagine this one cowboy, he or she or cowgirl, whatever, can manage like 10,000 cows, no problem, all with a gun in their hand while drinking whiskey, right? They can comfortably do that. And so they can comfortably manage tens of thousands of cows. However, on the other hand, if you have a sick puppy, how many people do you need to manage that puppy? The entire family, right, is taken and occupied in managing this sick puppy. And that's the difference between a data center computer and a cloud computer. A cloud computer is like a cow in a management of a cowboy, whereas a data center computer is like a sick puppy. What happens when your data center computer goes down? The sysadmin and his entire team are basically taking care of the sick puppy. Whereas in the case of cloud, if your computer goes bad, what do? What will the cowboy do? He has like 10,000 cows and he's like on a horse drinking and with a gun in his hand. What do you think he'll do? One sick
Shoots the cow and
Exactly.
moves on.
Shoots the cow.
Have steak.
I know. And so that's exactly what you do in the context of cloud. When your machine goes bad of some reason, right, like this authorized keys goes bad, you just shoot the machine and recreate your machine. And this idea is known as pets versus cattle.
So Neil,
Yes, go ahead.
so do we need it to really recreate the machine, or can we have a machine that's backed up and we just start up a new instance of a copy of the machine?
Either way. Either way, you can generate a new cow, replace the cow. Somehow replace the cow and find your way. But it is not your pet, right? You cannot replace a pet, not possible. But cow, who cares? And by the way, yeah, that's if there is an Indian in the team in the class, I am sorry, because cows are supposed to be holy and all that. But yeah, whatever. So you get the idea. The idea is pets versus cattle, which is the idea between data center and cloud. You treat your cloud computers like cattle, and when something goes wrong, you just shoot and move on. That's the idea. That's the fundamental idea I think you should take away from this cloud business is, what? Something goes wrong, just move, shoot, kill, move on. Because it is so easy to start a new machine and recreate the entire infrastructure once you, of course, once you take this course. You will understand how easy it can be to just shoot the cow and get a new cow. Like a real life functioning cow, just like the old cow was, exactly like that, and keep on with your business. You can do that. And we will go through these steps as we build towards it. But that's the underlying way to think about it. It's a very, very different way of thinking, is not a pet. Not at all. I mean, pets are great and all that, but not for business. For business, you want to get cattle. So that's the quick way of thinking about machine out there, right? I think there is a comment. Okay, no chat comments. So back here, back in our management console, what we are doing is this machine now, if something goes wrong, like I shot myself in the foot, so what I'm going to do is instance state terminate and kill the cow and move on. That's what I just did, and that's how you should do. That's the way to think about operations or anything to do with business in the context of cloud, is just shoot and kill and move. Okay, next. So in our machine creation process, you saw these examples, and I am assuming that the concepts are clear in the context of just about any cloud. The concepts are same. You create a droplet, you basically inject your public key right there like this, and you add your key, like in this example, add your SSH key, and then you have to create a droplet, and then off you go. Same thing here. And by the way, I noticed Google now has Windows there. So you can actually have Windows Server running in Google Cloud, which is nice. If you're interested in running Windows and you still want to use Google, you can. So you can see that the image is available for Google as a Microsoft Windows as a choice. So at top of the hour, I think we should take a short break before we switch the idea to another example and another concept we'll illustrate. So we'll break right now for 5 minutes and come back at 9:06.
Hey, Nilesh.
Yes.
I actually had a question about what you ended on this last topic. So you have your Cloud Genius website running on an Amazon instance. What happens if the underlying physical hardware that your VPC is running on fails? Do you have that backed up? Do you have it versioned somewhere else in order to protect against a possible failure in the data center?
Yes, I'll tell you what I do. Here's what I do. So if, for example, I'm just fictitious example, right click on this and action, instance state, and terminate. If I just do that, simulate that, what can I do? That's the question. And I'll tell you what I exactly do. I'll illustrate that. What I will do is I'll go to my folder where I have my Ansible code stored, and I will run these scripts. So I have some scripts written down that basically assumes that I have a blank new machine, blank new slate, blank slate as in empty box, like launch instance. Click and M4, where is M4? M4 large, that one, and click and click and click and click and add some storage, maybe make it 32 and click. And this is like a backup plan and click, and my security groups and click, and then I review and launch. And so here we have a blank new slate, right? We got a blank slate. Then I will run these 1, 2, 3, 4, 5, 6, 7, 8 and push. And these 8 steps followed by a push that I have basically brings back my site like this. Just like that.
It's all written. All those scripts are written in YAML.
They are written in Ansible. So I'll tell you.
Oh, is that why? Oh, okay.
It is YAML, yes, Ansible. So it's YAML. I can illustrate what I have inside right there. This is the code. It's very simple. Create user, the first one. So I have some, oops, too small. Okay, there we go. So here what it does is forgets that Ubuntu user that you get by default. I don't want that, so I will switch to some other user. So I'll switch to a user I like, not Ubuntu, but something else that I like.
So you have to create. But you have to create that user first.
So that's the script. It creates the user.
Oh, okay. I couldn't see it. All right.
Yeah. So I will go back and make it listing here. So here we go. First step, create a user. Second step, it's called update wallpaper. Yeah, but that's not the actual function. It does updates the machine. Second step, I add some dependencies that I need. Then I add some other software that I need. Then I add Linux Brew. Then I add Python. Then I add Docker. Then I install WordPress. And then I push my content. And off we go. Now, when I want to push my content, I need to have my content already. And I can get my content from an existing site before it dies. So here, Ansible, playbook, and grab my content, pull my content. So I'm going to pull, and here it comes. So it is going to my live website and pulling down all the content. It's taking a MySQL dump, database dump, file system dump, everything, and pull it down right here on my laptop. And then I have a copy. And so whenever I want to push like this, then I can just push and I'm done. So automation has been already established.
Okay.
That's cool. But now, is there any reason why we can't have an actual image of the virtual machine saved someplace and just plop the new image in place?
So imaging is a fine technique. Fine. So you have a working computer. You have this machine running already. Is that what M for large instance? You can take an image like this. So you can basically go to the machine right here, EC2, running instance, that machine, and then right click on it and say image, create image. And here we go. Image because Patrick wants one. And
Okay.
and then you can reboot or no reboot. I think no reboot is a bad idea. It's always a good idea to just allow it to reboot and then take a clean image. So I will allow an image, and my image size is like 32. And then I'll take an image because Patrick wants one, and I click the create image button. It will shut down the site, take an image, and then restart. So that's what was happen. Right?
Is that not a good? Is that not a best practice then, to just have an image rather than rebuild a machine that needs to be replaced?
So it is a practice. I don't know whether it is, you can call it good or bad, but I can tell you pros and cons. Okay, the pros and cons are, if you take an image, then you are basically logged up to Amazon Web Services, because all you can do is bring back the image to life, but only on this cloud. You are married, right? You're married to Amazon. And the way I think, the way I operate is I never get married, because I don't care about any of these companies, honestly.
Cool. Okay, that makes sense. Cool.
And so by doing it this way, I don't even care which cloud I go to. I just need a box, and I just run the script. It will bring the thing in that location. Whatever box, whatever cloud, my own desktop here in the office, or some computer in somebody's backyard. I don't care, because I'm not married, because I don't want to get married. I want to remain neutral. And that's the pros and cons of taking an image. You're locked up for life.
Makes sense.
Cool. So image because Patrick wants one. I'm not creating that image. I don't want any. There are images, they'll show up in the snapshots, and I don't have any images because I never create them because I don't believe in them. It works, by the way.
You're just taking the raw data, the raw content, and not the underlying platform.
Correct. And so my raw data, my raw content just got downloaded, by the way. I just ran that pull script. So I ran this pull method and it pulled down and it was all succeeded. And let us see what it brought down. Let us see. So here it goes and gets saved in this location. And at today, right now, it is the 20, what's the date today? 23rd. Yeah, so the 23rd, there is this SQL file, and there is this tarball, which is basically a tarball of the code in the site. And the SQL file is a database dump from the site. And so you have the whole file system come down. Only the application, by the way, it is very small. The ball itself is very, very small. If you look at the size of the files, it's not big. How much it is? It is like 6409. Yeah, so it's about how much? 1, 2, 3, 4, 5, 6.
6 megabytes.
Yeah, 64 MB of database and 53 MB of file system. That's it for 23rd of January. These two files. 64 MB and 53 MB is nothing. Right?
Well,
so quick.
What if I'm running a mission critical? So downtime has to be absolutely minimized. Is this how much slower is recreating the machine rather than having a backup machine that you just restore?
So you just asked me a question about criticality. Yep. This approach that I have is not critical. Not critical.
Okay.
When you're critical situation, you would have is a machine 1, a machine 2, machine 3 in 3 different locations in 3 different continents up and running at the same time, but have the one active, and these are standby.
That makes sense. Okay, cool.
I was going to say, so I have a server that's running in my group, and we have 2 machines for it, but a virtual IP address, and basically it's just a failover group, and that virtual IP address will map to the active server. So I guess that's like one way to handle it.
Yes, correct. In fact, that brings us to this point about DNS, because that's a way to manage it. So you have this site called b.a.cloudgenie.us, right? That's the domain name. And it's kind of hacky, right? It's very, very hacky. My actual domain name is cloudgeni.us. That's the domain. And what I have done is expanded it to this additional A record. So there is an A record or address record like White House and 1600 Pennsylvania Avenue. This is an A record, the name White House and the address 1600. This mapping is an A record. And so the mapping of let me show you. This mapping is also an A record. What I just did was type dig, D-I-G, and followed by the name of the domain, followed by a query for the A record. So this A corresponds to the A record. And what I got an answer section is that this name maps to this IP address. And I just did that because I wanted to find out what is my relationship, what is my A record. And so that's the response I got, A, back from here. And that's the IP address, 2319. Let's go match it here and here and here and here. And you can see it right there, 2319. It's the same IP address that you map and that you can see dig a record and the answer. So where do these entries get stored? By the way, this is universal and on the internet across the board. This is the DNS system, which is what we were talking about. Is what you can potentially do is, in case of a standby failover situation, you can have the DNS pointer change from this machine over to this machine in case something goes wrong. You can flip the DNS over. And so that's exactly what I will do in case I have a high criticality. I will have multiple machines, machine number 1, machine number 2, machine number 3, all ready and active, except the A record will point here right now. And when something goes wrong, I'll just erase this and say, okay, here, or maybe here. And so that record called the A record, or also known as the address record. This address record is stored in a file called the zone file. And this zone file is maintained by your DNS server. And the DNS server, in case of Amazon, is called Route 53. In case of Google, they call it Google DNS. In other companies, they have other names. Like, for example, DigitalOcean. I think they also give us some networking choices, and you can put domains. But I haven't actually used this one. They're building it up right now, so they have floating IP method. But this is very primitive. This is comprehensive. It's coming up. It's called Route 53. Excuse me. This in Google is also very comprehensive. It's called Cloud DNS. I am not using it, but you can create a zone file and give it a name, and you can say apple.com. And create. So if you create an apple.com domain, will you think they'll allow you to do that? I don't think so. Even if you create an apple.com DNS entry in a zone file with that name, it will still not resolve. It will keep on using this server that Apple maintains. Apple actually maintains these 3 servers, 1, 2, and 3 for their name servers. And that is where the entries will keep going to, even if you even if you claim that you are the owner of Apple, but you cannot prove your ownership, so the thing will actually not work. So when you want to create a zone file, you want to actually have the rightful ownership of the domain. You cannot use Microsoft or Apple or just about anything unless you actually own it. So in my example, I own this domain. Which means I can create a lawful DNS zone file entry in some provider, such as this Google, or here in Amazon. Apparently I got logged out. So I'll log in again. And in that zone file, you can see that I already have a zone. It's the DNS management. I have one zone already created. The name of that zone is cloudgenie.us. And I have about 101 entries in that. So let us go and examine what it has. So I'm going into the zone file. And in that zone file, the entry that I would like you to see first is this entry right here. you can see that this entry is an A record entry. And it is basically a relationship between the name and the number. It's like the White House and 1600. That relationship established right here in this location, and that is what results in this query. And the answer b.a.cloudgenie.us goes to this. And that authoritative answer becomes possible if you have an entry in your zone file for your domain corresponding to an IP address in an A record in your zone file. And so when things go wrong, like for example, this machine goes bad and you want to switch to this machine, you want to find out the IP address of this machine and come back here and make a change to this address and put in a new answer, something like this. So different IP address, and then you save. The moment you save, the references will switch from V1, it will switch away to V2, virtual machine 2. And that switch over will happen and will globally propagate in 60 seconds. And that's the time that you need to allow for global propagation to happen. And within a matter of 60 seconds, the switch will happen. Now, I do not want to actually make a switch right now, but that is how you do it.
So can that be done automatically? So if we identify a failure, it can do it, or does this have to be done manually like what we just saw?
Right. It does not have to be done manually. It can be done manually. It does not have to be manual. Most cases in large companies, this change is done automatically. They will detect a failure. They will automatically switch over and come here through API, make changes to this number, to another number, and move. And so that transparently happens, that change of IP address in case of a failure. You need to program it to happen automatically because nobody has the time to actually respond within a matter of 60 seconds to actually switch over. A person can be slow. So you have to do it automatically in the ideal situation. But right now I'm illustrating the fact that you can do it manually also.
Yeah, cool.
So now that brings up a good point, which is, do you have a domain name already? Because if you have a domain like this, we can have some fun. A fun as in, by the way, a domain name can be purchased for $1. Roughly, sometimes a little bit more than $1. But I would like you to have a domain because it helps you in experimenting with a real name that you can use with a variety of different records in a given DNS system. And for example, if you have, we have an exercise coming up that will allow us to play with our own platform as a service. So like platform as a service. So you may have seen that it is, so I think you may or may not have seen, but the key is if you have a domain name, it makes it a little bit more interesting to experiment with all the aspects of dealing with machines, including the records that we need to play with a DNS. Now, in order for us to get a domain, the cheapest way, I think, is, let's see, cheap.
Dynamic DNS, I think they'll actually give you a free one. At least they use it.
They will give you a name, but that is not going to be your name. I would like you to have your own name. And the best way to get a name for yourself is to select your last name, such as londhe.com, for example, which goes to this site. But having said, these guys are giving you a domain for 99 cents. And I would not hesitate to get it. I would suggest that you just get a domain like this from GoDaddy for a 99-cent price. and do not, oh, you already have that. That's great. So some of us already have a domain name, redmondturcat.net. That's beautiful. And let us go examine this domain. So what I'm going to do is play with redmondturcat.net. Let's see what do we have. So dig redmondturcat.net and off we go. So let us examine what Patrick has done. So Patrick is hosting somewhere in this IP address. Let us see where Patrick stores his email.
That's my Exchange server.
And
My
so,
virtual machine.
right. So here Patrick stores his email in mail.redmondturcat.net, which happens to be, I don't know where, some machine, but that's the IP address for that machine where the email goes. And then let us see some other things such as your name server. So you're using Dyn, which is a dynamic which is a dynamic DNS service provider as a DNS company, which is a good one. They are also similar to Route 53, for example. So Dyn.com will give you that as a service, which Patrick seems to have taken. The scenario that I'm basically pointing at is that it allows us to play with domain name records in conjunction with machines and services that we'll be using. So having a domain with you is going to help, not just for this class, but for one simple thing that I would suggest, which is I would describe this like this. To build your brand, your personal brand, that your name. And so redmondturcat.net is one example. Having your name and your web presence is important today. The idea is to have somebody search yourself on the internet, and all the things that pop up are corresponding to you as a person. And that is important. That is important because it gives web presence to your personality. And I think that cannot be understated. You can read more about what I'm talking here about personal branding. And it is in today's generation, in today's business life, it is super critically important for us to have our own personal brand on the internet. Having a domain name helps you build that with your own domain with your name. And that is what I'm suggesting that you do. So this is a side, actually this is a primary benefit. The side benefit is that you can use your domain with a variety of different cloud services. And so we can play with A records, MX records, name server, and a bunch of other types. We'll do some exercises on that once you have a domain. So I strongly suggest that you spend $1 and get this thing. I'm going to paste that link for a quick spend of your $1. Make sure you do that. I think it helps. It helps. If you do not have a domain, get one. And this, by the way, is only for the first year. For the future years, the pricing will change. They will probably charge you $10. But just saying, just cautioning you. First year pricing, when you buy a domain, it's going to be 99 cents. And as you click the buy button, they will try to sell you this and sell you that. Don't have to buy anything else whatsoever except the name, except 99 cents. Do not pay anything more than 99 cents, but get a name, please. Now, having said, let's get back. The thing that we are discussing is to understand how these records come into play in terms of allowing us to dynamically change from machines that are dying to another machine as a backup in real life. And this process of changeover can be automated. And the change happens in a DNS record, specifically in the A record type. That's where you will change for a site to fail over, like this. And for that, of course, you need a DNS and a place to store the records, the zone file. Now, having said that, let us get back to our main discussion here, which is continuing along in our compute services. Before we switch away from compute onto storage services, I would like to ask you a question about this clarity in understanding about how do you size it, how do you get the CPU, the storage appropriately sized, and how do you get the IP address, how do you inject your key, how do you connect to it. Those, if there are any questions around those aspects, what are known hosts, what are authorized keys, if there are any questions in that aspect, please let me know. And with that clarity of understanding of basic connectivity to a compute resource, I'm now changing the topic from here over to storage as a service. And so I'm changing this. If there is any question on this, you can keep them coming in chat or in any which way you like. Now, the concept of a storage, as you saw briefly here when you start creating a machine, you see that it lets you select the size of the storage like this. Add some storage. Here you can get 128 GB of high performing SSD and all that. And so any amount of storage you can add, and this is like your C drive, right? You get a machine, you get your C drive connected directly. That's what we are talking about in here. This is called elastic block storage, and this is directly connected to your machine. Now, having described that idea of storage, there are a couple of different other types of storage available on the internet, and one prominent example is called object storage. Object store. And the idea of an object store is literally as ridiculously trivial as this. You have a bucket and you put an object in the bucket. That's what the entirety of the idea is. That's it. It is as trivially simple as putting an object in a bucket. That's the concept. That is called object store. And what does that boil down to in real life example? Let us see that. You have a picture and you want to put that in some folder. You just do that, right? You take a picture, put it in the folder. That's the bucket conceptually. And this is the object. So you take the object, put it in the bucket. That's the concept in real life. You're probably familiar with this idea. Except this folder can be on your C drive or maybe D drive or some other drive on the network. And there is this folder, and in that folder you put the picture. And that's how you are probably very familiar with. Except in the case of the internet, you may or may not want to have a NAS or access to C drive or access to D drive for a simple reason, which is pets versus cows. You want to not deal with pets, you want to deal with cows, and you want to kill cows, literally kill. You want to kill them and get new ones, new cows. And you can do that provided you are not tied to C drive or D drive. If you're tied to these drives, then you cannot kill the cow. So you want to have a method in which you are not married to the pet, but rather you remain agnostic. And keeping yourself agnostic, keeping yourself in a fashion where you can actually afford to kill the cow. when you can afford to kill a sick cow, you can actually afford that, provided you don't have an important picture stored in your C:/Windows/whatever/pictures. Because if that is the case and you kill the cow, this picture is gone. We don't want that. So what do? We store the picture away from the cow. So that we can kill the cow. Sick cow, dead, move. The picture is safe because it is kept away from the cow. The cow doesn't have the picture. Similarly, in this example, here. No, not here. Here. If you look at this picture, let us right click on it and see where the picture is stored. Copy image address and open an editor and paste. Let us see where the picture is stored. Now compare. What is the name of the website? And where is the picture? Can you spot the difference?
Yeah, your picture is in your CDN somewhere in a cloud.
Correct. And the CDN is storing a folder which has another folder which has the picture. And this cow can be killed like this because the picture is outside the cow. The cow doesn't have the picture. You see that? If I actually destroy the whole machine, my pictures are safe. My content is safe. My data is also safe. This machine is basically just a machine because that's all I care for is some CPU horsepower. And my data is outside. So I can afford to kill the cow. And so you can enable this by putting your objects in buckets somewhere outside in a different service. It's a different service altogether. It has no connection to EC2. It has no connection to Google Cloud or Google Compute Engine. It has no connection to DigitalOcean Droplets. Because these items are basically those cows. I want to be able to dispose them off and get new ones anytime I feel like. But I'm storing my objects in a bucket provided by a service. It's a different from these guys. Not this. Something completely different. The service that these guys give me is that they give me a bucket. A very reliable bucket. A very highly available bucket. A very affordable bucket in which I can put my objects and I am happy. A very affordable, as in we can see the pricing. You will laugh at the pricing. It's very cheap. And so most companies in the cloud will give you a service to store stuff. Let's call this stuff. You can store stuff like a picture in the bucket, and most people call it buckets. And you can put pictures, video, music, files, documents, zip files, starballs, code, whatever you want in the bucket. And it's a different service. There are several examples of it. Simple storage service from Amazon Web Services is one example. Google Storage, Google Object Store. Let's see the name. The name is, the exact name, sorry, the exact name is coming up. So Deepak has a question. Go ahead. Go ahead, Deepak.
So take a scenario where I'm running my desktop on cloud. So the user profile data, will it be inside the cloud or outside?
You are running your desktop on the cloud. Okay. A desktop on the cloud is a different type of service. It's called desktop as a service. Some companies such as Amazon will have a solution for that. And let us go look at this. So the examples that I'm giving are not related to desktop as a service. But in Amazon, they have this thing called workspaces, enterprise applications, workspaces, desktop in the cloud. And here you get Windows 7 ready. And through RDP, you can launch a workspace, and that basically gives you Windows 7. Oh, I need to create a directory and all that. But the idea is you get a Windows 7 remote desktop, pretty much like access to a remote computer through RDP, or other people call it terminal services. Or you can type on the command prompt in Windows, type MSTSC, enter, and you will see what I'm talking about. It's called Microsoft Remote Desktop or something like that. That's the binary.exe is what you run. So through that binary, you can then connect to a remote desktop that some companies give you. Now, the examples I am talking about do not apply to that desktop setup. Do not. In a desktop setup, you are supposed to have everything local to your desktop, because that's what the convention is. C drive and D drive in Windows, that's what you will get. And that's where you will store. And those service providers that are providing you remote desktop as a service will make sure that they will back it up for you. So they will have a backup of your C drive and D drive. If something goes wrong, they can recreate that experience based on the backup they will take for you. So that service, it is a part of the service offering that they give. If something goes wrong, the machine dies, you can recreate the state of the exact machine with the file on your folder all inside your machine, and you don't have to worry about the simple storage service or the object storage services, because this example is for server-side applications. You are discussing an example of a desktop as a service, which is a client-side scenario. Okay?
Got it.
Cool. So back to our discussion, which is to be able to use a service called Simple Storage Service from AWS, or in case of Google's example, the name that Google chooses is called storage. And they have this idea of a bucket. And I have a bucket called Cloud Genius. And I can create more buckets if I like. And how do I create a bucket? I just give it a name. And then I create it. That's all it takes to create a bucket. So here we go. I just created one. And so now I have two buckets. I have a bucket called Cloud Genius, and I have another bucket called Give It a Name. There we go. And there are no objects in the bucket. What does that mean? It contains nothing. Now, how do I add content? I'll just upload some file, click, and say that I want to upload my, okay, what do I have? Pictures. And so I will upload this picture and choose. So it is uploading the picture, and there it is. My picture is now in the bucket called Give It a Name. I have the.
So Nilesh,
yes.
Quick question. So when you say this service is completely separate, what do you mean by that? Is it on separate hardware, guaranteed in a contract, or is it just notionally separate?
It is a separate hardware, and it is guaranteed in a contract. And I'll tell you the contractual guarantee of an example of S3 availability. Let's read the contract. Okay, Amazon services, and see the contract they are claiming. Okay, so here the reliability guarantee. The reliability guarantee S3 standard is designed for 99.99 availability, and the other one is designed for 99.9 availability. Both are backed by this service level agreement. So it's a completely separate service, very different from your EC2, very different from your Google compute engine VM instance. So here the VM instance, these are completely different from the the storage service you have. From Google, you have the storage service in which you have these buckets, and they are completely different hardware and a completely separate SLA. Even if you kill your EC2 machines, these services for storage are going to remain and persist. They are
So
persistent.
are they in the same? Is the hardware in the same data centers as the rest of the AWS stuff or the rest of the Google stuff?
We don't know because they don't tell us. But
okay, so all they guarantee is reliability.
Correct.
And availability.
Yes, and they store it in multiple places, and probably 3 to 4 different places replicated.
Sure.
And that is one of the reasons why it gets a higher availability. And so in this example, you have this name called bucket name and the item or the object inside the bucket. Now, right now, we will discuss about permissions, like who can access the object. And so by default, everything is private, meaning only I can access this object in my bucket. That's the default, private to begin with, unless I decide to make it public. And so I can do that by clicking the item, the object, and saying, please share it publicly. And now I have a public link. And so I can grab the public link, and here we go. Paste it over and give it to the group. And so you have the public link to my object right there. There is a question from Rebecca that's coming up. So go ahead, type it, please, or say it.
Oh, okay. I was going to type it. So I was just wondering how would one consider the performance of their website, for example, if they've got their pictures in a bucket in Amazon Cloud and they've got some of their content in Google Cloud, but you have to be able to load all that into, the UI. You're kind of relying on network performance, right? So, and I'm using a very simplistic example, but what I'm thinking about is you have really, really large videos that you have to upload.
Yes.
So I'm just wondering how the performance on the back end is considered.
So when you are looking at the back end, I will clarify that you are actually dealing with, say, Google Storage or the performance of Amazon Simple Storage Service. And so you're basically discussing, when you say back end, you're actually referring to the performance of these guys, and and not the performance of the EC2 machine or the Google instance, right? The Google instance may also have a place where you can have a block storage, and the EC2 can have a block storage. You can put a picture here, but that is not what we are deciding to store. We are deciding to store it outside in a storage bucket, either S3 bucket or a Google storage bucket, and the performance is pretty darn good in my study. It is actually better than what you would get from the actual access to the direct machine, because they have optimized it primarily with the purpose of having it distributed. Now, having said, the performance is still not great enough for a globally distributed scenario. And for that, we have this other thing called content delivery network, and they will come up to supplement what you just have in your S3 bucket, for example, or Google Storage bucket, for example. The idea is these buckets are geographically limited. And that means if you have a bucket in Seattle or Oregon, then a person sitting in Jakarta, Indonesia, will have a hard time accessing your object in these buckets, because this is going to be tough, right? And that is going to be tough also, even if you have an EC2 machine with a disk, and that happens to be sitting in Oregon or Virginia, it is still equally hard for this person in Jakarta, Indonesia, to access the item that you might have either in EC2 or Google Storage or S3. It is still, this geo problem exists. So there is a way to avoid that geographic limitation of distance. And that is where this concept of a CDN comes into play. We'll switch, momentarily, in maybe 10 to 15 minutes, we'll switch to CDN as to how it helps this guy in Jakarta or how it helps this guy in Bangladesh, for example,
Okay.
to understand that an item stored in Seattle in a bucket called whatever that name is, give it a name, bucket, and that item that I have the picture. And so make sure that this guy is all happy in accessing this item, and so is this Jakarta guy. We want to make sure that they are all happy in getting good enough performance in downloading these pictures, even though they are stored in Seattle. And how do we do that? How do we address that? We'll see with live examples just a moment. For right now, let us complete the discussion about putting the object inside a bucket and understand that they are different from a disk connected directly to your EC2 machine. They're different, just different computers, different services. And the model is that, you have this example where I just pasted in Slack chat. You have a bucket called give it a name and an item called 000, whatever our clouds considered. That's the picture, the object that I store. In line number 7 is the item, the object. In a line number 5, bucket name in a service called the Google Storage. Similarly, here I have an example called something, something, something. This is a CDN example. So let us hide that for now. And let us compare the analogous S3 example, and I'll create that right now. Hold on, let me see the S3 example here. Let me put a S3 example just like we have the Google example here. Let me also illustrate a Amazon example of putting an item, the same item, in a bucket called give it a name. So we'll do that right now, and it's coming up. The question about encryption, I will get to that just a moment, please. Deepak, hold on. And so the example about S3, we'll go to S3. And here we'll first create a bucket. The bucket is called click. And I'm going to call it give it a name. That's the name of my bucket. And so I'm going to create it. And now I have the bucket called give it a name, and it is empty. It has nothing. And so I am going to add something to the bucket by uploading an item called click and upload. So now it is starting the upload. It finished the upload, and I have the item uploaded, and it is in the bucket. By default, the bucket and the item is all private. It is logged up, and I am the owner. But I can change permissions and add more permissions for public, for everyone to be able to open the file so they can see it. And if I do that and I save, then the permissions become public. People can see it. What does that mean? They can click this link and grab it. How does it work? Let us go paste in the Slack chat a different link and now compare and contrast these two links we have in our examples. So we have a Google link right there and a different link, this time from Amazon Simple Storage Service. The link is conceptually very similar. You will see it. You will see that in line number 5 and line number 16, the bucket name. Line number 7, line number 18, the object name. They are same, except the services are different. Number 3, Google Storage. Number 14, Amazon Simple Storage Service. Concept is very, very similar. The idea is to have a bucket and put an object in the bucket. And by default, everything is private unless you explicitly open it up. When you open, everybody can access. Now the question about encryption. Will the object be encrypted and stored in S3 and Google Storage at rest? Yes, it is encrypted by default. And yes, it is accessible only to the creator by default, unless the creator decides to open it up for access by other things, objects, people, services. And that's the overall concept in terms of an item that you put, an object that you put in a bucket in a service. Very, very similar, except lines number 3 and lines number 14 are different. Concept is the same. Performance is very similar. Pricing is also very, very similar. They are undercutting each other, and it is a great thing that is happening because the prices are going down and we can benefit from it. So we do that. Now, let us also do the same trivial thing, which is to create a bucket and put an object and generate a link by sharing it with everyone. Do that in Google Cloud, do that in Amazon Cloud, do that somewhere, wherever you feel like some object storage service. Make use of it. It's trivially simple. Put an item, share it. And that's the concept behind using these buckets and these storage services. The idea is we are basically using a storage service from some companies, Google or Amazon or whatever. Microsoft also has a service similar to that. Let's see that if you have easy access to their Kluge interface. I don't like that interface, but where is that?
Can we take a quick break? Can we take a 5-minute break?
Yes, you can. And in the meanwhile, while you're on break, I suggest that you please take an item, put that in a bucket, and share it in Slack chat. In the meanwhile, I'll figure out what this Azure link is. There's a similar service in Azure, so I'm going to go and explore. We'll take a break at right now and come back here in 5 minutes, which is going to be 10:02, 10:02, whatever. So it looks like Google, what is this company? Yeah, Microsoft also has the same tool set. Storage, bucket, object. They call it blob for some reason, but whatever. It's the same idea. So Patrick has given a private link, and I don't think we can access your private link, Patrick, but we'll try. You have to make it public.
So, okay, I'm looking at permissions, and it says you can control access to the bucket and its content using access policies.
So
add.
yeah, so click the permissions and open it up, and right now everybody will see something like this.
There it is.
So access denied. So private link doesn't work for us. You
Right.
have to make it public, and only then we can see your object. Otherwise, not possible.
Try it again. Try it again.
And it worked. We are looking at a cloud of some sorts, right? It's a picture of a cloud.
Well, it's actually
Oh,
it's on top of a mountain.
Oh, nice. Okay.
Cool.
And you can disable permissions after the fact. After you open it, you can then say, no, I don't want to share it anymore, and you can disable that. That also is possible.
Okay, cool. So I removed that permission, and now if you tried to reopen it again, it would say not available. Okay, cool.
Nilesh, are you able to access the link? I think I'm getting an error.
Yeah, you try the second link and it'll work.
What is the second link?
Look at the chat. You have a typing mistake. You have a txt at the end. You do not.
Oh, okay. So I gave the permissions at a file level, not at a bucket level initially.
You
So
can
how does it work?
you can put bucket level permissions also, but for right now you're dealing with the file level.
Right. So that's what I did with this one. Is I guess I went to actions and make it public.
Yep. You can make the whole bucket public.
True. You can. That's what my truck wants to look like when it grows up.
Nice.
You can tell mine's already really old.
Yeah. No, it's got a couple years.
Nice. So my truck looks like this.
I saw one of the SUVs on the island the other day, and it caught me. I saw it, and I didn't realize until it turned, and I saw the badging. I was like, "Oh, that's the new Model X." That was awesome.
Yes.
Yeah, those are pretty cool.
Yeah, it is a pretty darn cool car. I mean, this is amazing. I mean, I cannot stop talking about it, so let me just shut up. But
So now, Neelish, when it can go 1,000 miles without a charge, then I'll really be impressed.
you can go 1,000 miles, but not without a charge. But the charging takes 20 minutes. Charging
Oh,
takes,
really?
yeah, 20 minutes. And you can
That's
go,
not bad.
yeah, it's not bad at all. In fact, you can go from here to San Jose, no problem, because every 100 miles there is a charging station. And you can charge up 20 minutes, have some lunch or something, and move.
Well, now, you wouldn't want to go 100. It would be like, what, 300 miles? Every 300 or?
Yeah, the range is 300. The charging stations are every 100.
Cool. That's not bad, actually. That's not bad at all.
Yep. Okay, let's get back to business. So what we are dealing with essentially is putting an item in the bucket and adjusting its permissions, right? Allow access, disallow access, things like that. You can do it very granular, bucket level, item level, object level, whatever you feel like. And almost all providers like Microsoft, Google, Amazon, they'll all do the same thing. They'll call it something different, like these guys, Microsoft storage people will call it a blob, like here, like blob, create. And you can give it a name and then create a storage account and then put the item in the bucket and all that. It's the same concept, same permission set, same linking and everything. Now, let us extend the idea to something slightly different. And that is this geographic problem, right? So the simple concept behind making sure that a person in Indonesia, a person in India, or Bangladesh, those guys are far away from here in Seattle, and so you want to make sure that content is distributed globally. Content distributed globally. How do we do that? We use a content distribution network. There are several companies that do this business. Like almost every cloud provider will have a content delivery network service. Now, what do they actually do? They will take an item or an object and make it globally available. What does that boil down to? Is that if I have this bucket called give it a name, then I can decide that this item that I put in the picture that I put in that bucket, I want to make sure that this item becomes available from Seattle to every location worldwide. And I'll open up a map here. Hold on just a second. So you look at this picture. And so I have this item here in my origin And what I'm doing is using this content delivery network, I'm replicating to a global audience. And what does that mean? It means that the original item that I have in my origin bucket, S3 bucket, it gets copied over to these edge locations. Edge, edge, edge. Wherever the edge locations are, every content delivery network will have a certain number of edge locations. That is where this original content will get copied over and become available locally to people far, far away. What does that mean? It is basically caching. It is caching. What does that boil down to? Is when you have this picture P1 in the bucket B1 first time, this guy in Jakarta will take a long time, like long time, to download, and will be able to see the picture P1, and it'll take a long time. And that is going to be from this edge location in Singapore. And so the Singapore location will get a copy of the P1 file, a P1 object, copied over. The first user in Jakarta will take a long time to grab the P1. The second user in Bangladesh will also get the item P1. However, because of content delivery network, this Bangladesh user will not take a long time. Instead, they'll take a short time to grab the picture P1 from Singapore. That is the location that is in geographic proximity for the Bangladeshi dude. And so the first time, this poor guy, Jakarta person, takes a long time and he is frustrated. And that is unfortunate. But that is what is known as a cache miss. Next time, the Bangladesh person comes in and he or she gets a cache hit. And if it is a hit, it means the item is available in Singapore. If it is a cache miss, the item is coming from Seattle.
But if the guy in Bangladesh tries to hit that again, would your browser cache take it back to Seattle, or would it automatically hit the Singapore cached picture?
So caching happens at multiple places. One of them is in the browser. But we are not talking about the browser cache. You're talking about
Right.
CDN cache. Now the CDN is smart enough. If you look at this example, I have a reference to cdn.cloudgenie.us. Now let us see what does that boil down to. Let us see what that means. It means if I dig cdn.cloudgenie.us, I'm getting an A record reference, which the answer is actually not an A record, but a CNAME entry, a canonical name. A canonical name entry is, if you're not familiar with this, it's like Robert and Bob, or help me here, please, with more.
Michael and Mike.
Rebecca, Becky.
Exactly. Michael, Mike, Rebecca, Becky, things like that. So these are canonical names. These are aliases. And it is simpler to call Robert Bob. I don't know why it is Bob, it should be Rob, but who cares? So the aliases. Aliases make it simple because if you have a name called Venkatesh Narasimha, some long Indian name, right, you will be having a hard time to say that name. Instead, just call him Venki. Simple, right? So that's the alias. And here, in my example, my simple name is cdn.cloudgenie.us. That's a simple name. I hope it is simple, like Venki. But it is not Venkat Narasimha Raju, whatever that long name is. So that is what we are looking at here. Look at this. Blah, 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 whatever, .cloudfront.net. I cannot even remember that thing. And so that is why I have put this friendly name, CDN. It's like Venki, it's like Becky. Because I cannot remember Rebecca. It is too complex. And so this is the complex CloudFront endpoint that I don't need to remember. But I have put a friendly name. That's one part. The other part here is that this CloudFront entry is actually a multi-A record entry. Look at all these IP addresses. They are geographically distributed worldwide. For every name that maps to, the nearest one based on geographic proximity is automatically picked up. And if you do not find the item in Singapore, it will go to the origin and grab it from Seattle. If you do not find it in the edge location for the Bangladesh person, the item entry from DNS will go back to Seattle origin here and then pull down. That miss. That was a miss, by the way, miss. Because you have to go to Seattle all the way to grab it, and that is a opportunity miss. And so that is why it is long time. As in not really noticeably long, but I'm just saying it is still fast enough for most people. But when you're doing these things repeatedly over and over, the transportation from Seattle to Bangladesh can be a long time, subjectively long. And so we want to improve the performance, and we will apply this concept of a content delivery network in place to make sure that subsequent requests for the same object do not have to go to Seattle, because we will keep a copy locally in Singapore. And that is called a cache hit. And it is faster to go from Bangladesh to Singapore than to go from Bangladesh to Seattle. This is CDN acting and serving from here, as opposed to a miss. This is a hit. And hit is faster because of the locality of proximity to Bangladesh. You get the idea, right? Do you?
Yes.
Okay.
Question, Nilesh.
Yes, go
And
ahead.
the second time the person goes to bed from Bangladesh, it'll be faster for them as well, because their browser doesn't have any idea that the actual document came from Seattle on the miss.
Correct, because browser all deals with this link, this point, right? So if you look at this entry here, and I will now do a trick. I'll watch my trick now. What I'm doing is, first of all, you know that this entire link corresponds to my picture. So I will now hack the URL pretty much like this. Watch me. So I modified the URL, and I'll take it to a browser and paste. Right? The same thing pops up that you will see when you go to this. It's the same object, except the representation in line number 3 is through content delivery network alias, and the actual CloudFront object is from that weird complex name, which I cannot say, line number 2. However, let us go to the origin now. So we'll go to the actual origin, which is not the CDN, by the way. This is not this is the CDN. This is also the CDN. Line number 3 and 5 are both CDN. I want to now go to the origin file. The origin file has to be in my bucket somewhere, because I will now look at my content delivery network, CloudFront. And here I have 4 CDNs. I'll just use one of them, the one we are talking about, this one. And we'll go inside and identify the origin. The origin happens to be a bucket called S3 origin. So we'll go to that S3 bucket called Cloud Genius. And that bucket is in S3. And it's called Cloud Genius. And there is a folder called, whatever it's called, WP content. Where is that? WP content. And then uploads. And then inside uploads, we have this file called NL, click. And that's the file, nl.jpg to be specific. So we'll look at the right file, not this, but this. And now click on this link and then check its properties. And the link is right there. So we'll grab it, copy, put it back in our editor and compare. And so see the 3 things. The first one is the actual origin. The second one is a CloudFront representation, a CDN cover on top of the origin. And the third one is a friendly name for the line number 3. Or rather, I should say 1, 2, 3. So the first one is the actual origin item in the bucket called Cloud Genius in the Amazon Simple Storage Service. In a folder called WP content, in a folder called uploads, there is a file object called nl.jpg. And line number 2 is a CloudFront representation. It is geographically distributed, load balanced in these many different IP addresses worldwide. And line number 3 is the friendly representation of line number 2. Now you get that?
Yeah, isn't it, so see how the URL or the location of that Cloud Genius bucket is directly after Amazon S3? I was thinking that wouldn't there be something else denoting the region or some kind of account? Because then doesn't that mean somebody else couldn't have a Cloud Genius bucket as well?
That is correct. Nobody else can, because it is taken. It is taken. Sorry, but it's also my trademark.
Yeah. In fact, if you try to create one as Cloud Genius, it says it's not available. I've already tried that.
Yeah. Yeah, it is my trademark, man. I'll come after you if you take that bucket. I'm just kidding. The idea is these are they're globally unique names. It's a unique namespace. And so you are basically logged out. If the name is taken, it's gone.
So Nilesh, I'm just thinking of a scenario like if you upload a new image now, will it invalidate all the caches on the edge and will it force to pull from the source location?
You mean when you upload a new image, it will
Let's say you go now and upload a new image of yourself, right?
Correct.
Or replace the image that's there with the new one.
Aha. So
Yeah.
there are two different
I
questions,
just
right? One is a replacement, one is a new image. So you have to be very specific in your question. The question I think you wanted to ask was a replacement question, but I'll answer both. So the question is like this.
Okay.
Yeah.
Yeah.
So the two
Yeah,
scenarios.
sorry, it's not a new image, it's a
Yeah.
replace.
So we have a file called nl.jpg, right? And it is in a bucket called uploads. Sorry, a folder called uploads, in a folder called WP content, in a bucket called Cloud Genius. That's how the layout is, right? This is the bucket, and this is folder, and then object. So now, if you replace this file with a new picture, nl.jpg, same file name, but this is the old picture and this is the new picture. The moment you put a new picture, your content delivery network will have no idea that you replaced it. So it will keep on serving the old picture. You have to go and mark, or rather, there is a word for it. Hold on, let me get the word. You have to go and invalidate your cache, and that is right here. So no, sorry. Go back, CloudFront, CDN, invalidation, create invalidation, and here you type like this.
But why do you have to do it manually? Like, wouldn't it detect change in the content and automatically invalidate the caches on the edges?
Yes, it will, but not right away. If you want your users to receive the new image right away, you have to create an invalidation.
But it would do it automatically after some X seconds or whatever, or
Yes, after not seconds, but it's programmable. After a certain amount of time, invalidation happens by itself. But most people, most developers are so anxious that they put a new item and they still see the old item, they get anxious. Hey, why thing is not working? And so that's why they have this thing called invalidations button available, so that you can then put this WP content uploads /nl.jpg and then invalidate that item. That particular path gets invalid, and then it will pull from the origin, and then it will show you the latest. So invalidations you can read about more as to what and in what scenarios do you invalidate, and when do you don't have to do. But most developers are anxious. They put a new item, they want to see it right away, they don't see it, and the only way to get to that is to actually invalidate. Now, invalidation requires money. It costs money, so don't randomly keep invalidating your cache. So there is a cost to it.
But if you're a large organization managing a lot of content, you can't be manually going and invalidating content as it changes, right?
You don't have to. It automatically picks up. I'm just saying that if you do it right now, it will not immediately pick up.
Yeah, but if you're developing a website and want to see the changes right away, it can be pretty annoying when they're not, so you want to invalidate. It's like with your browser, if you're developing locally on your machine, you're going to clear the cache so you can see the changes that you've made.
Yes, in fact, when you are actually developing, it is a great idea to just disable all this CDN business, because you want to make sure your thing is ready, right? And so here is what I do is when I'm developing something or changing something, I will actively disable my settings and go to my caching right here. Where is that? Caching, and I'll turn it off. And I have CDN that is also automatically turned off as a consequence. So it will automatically disable that. Everything else, if you disable your caching, CDN also gets disabled, and you can test it thoroughly. When you're happy, you enable it back up, and you're okay.
there is no cost to invalidation if it's automatic, right? It's only if you force it manually.
I think you have to read about pricing, but the last I checked, there is a cost to invalidations. So just
even automatic.
Automatic, no. If you do it manually
okay,
like this,
just manual.
Yeah, through this interface, if you do go like this, there is a cost. Okay, let's keep going. So you get the concept. What I would like to now ask you to do is to put your own item in the bucket and put a CDN layer on top and make your picture go global like this. Like we're talking about this global thing. Where is that? Here, like this. What I would like to essentially very precisely ask you to do is to do these two things. Number one and number two. So put your item in a bucket, make it a link, and then put a CDN on top, and then make sure that the item reaches worldwide. That will give you a solid, clear understanding about how do you enable a content delivery network for an object you put in a bucket. So the two links I just pasted in Slack chat, the first lines number 1 and 2, are a representation. The first one is a representation of an item in your bucket. The second one is a representation of the same item, but through content delivery network, through a CDN. So second is what you have to figure out how to enable. I can give you some hints. It's very trivial. All you need to do is something like go to CloudFront, create a distribution, create a web distribution, and here you select your bucket. Like I'm going to select my bucket called Give It a Name bucket. Where is that? Give It a Name bucket, there. And basically now you read the whole thing and figure it out. If you get stuck, just let me know. It's very, very intuitive. Most of the buttons are already selected for you. You just have to give an origin name like this. This is the origin location, which is the bucket that you created. And then at the very end, you basically create a distribution. That's all it takes. Everything else is defaults. They're good. Origin path is optional. You just have to give a bucket name right there and hit enter, and that's all it takes. That's how you create a new distribution in content delivery networks. So click, create web distribution, select your bucket, the origin location, where you start from. Like in my example, it is going to be give it a name. And then I go all the way to the bottom and create. Boom, that's it. That's all it takes. And so what you're essentially doing in this example is that you already have a bucket created called Give It a Name. And you already have some objects in the bucket, or pictures, whatever you have. And you have done the part number 1, which is this line number 1 here. You already have it. The next thing is to put a layer of content delivery network on top, which is basically put a wrapper around this object and make it go global, like Singapore and all those countries, like worldwide, like this. So you make your bucket and make your item go global. And the cost to this is going to be 2 or 3 cents. And yes, you will get a bill. Even though you think that you have a free account and all that good stuff, I think they will generate a 2 cent bill for you. Something like that. It will happen in a month. And so make sure that you disable your CDN after you're done this exercise so that you don't pay more than 2 cents. But you're very
2 cents charge on a credit card?
Correct. Correct. You will receive that. And so you will receive a bill for 2 cents for use of this content delivery network from Amazon, even though you might have a free trial account. Because I think this service is not covered in the free trial. So just make sure that you are understanding clear that you are getting hit with a bill of 2 cents. Let's check the pricing on Amazon CDN. The more people will hit your object through the content delivery network, the higher you will get charged. So for the first, hold on, there is a free tier. As a part of free tier, you can get your own CloudFront for free. Okay, great, nice. So CloudFront is free with the free tier. That's awesome. So forget about 2 cent bill. I thought there was a bill. So no, you will not be charged 2 cents. But the pricing is for the first 10 terabytes. If the user who's watching is in US, you are getting a bill of 8 cents for the first 10 terabytes. If it is a European user, you're getting 8.5 cents. If it is Philippines, Hong Kong, Korea, Singapore, Taiwan, you're getting 14 cents bill. Japan, 14 cents. South America, 25 cents. Australia, 14 cents. India, 17 cents. So depending on this pricing model that they have, you will get hit with a bill if you are not on the free tier. For the free tier, I think 50 GB is free. I think your picture is less than 50 GB. So you don't have to worry about it. So don't worry about bill and just create a CloudFront distribution and make your picture go worldwide and make that Jakarta guy access it. The access will become possible through link number 2 or something like that. This is where you will see generate after you have a CloudFront distribution created for your bucket. So post a link and make a CloudFront worldwide distributed cached representation of your object in your bucket. And what you are essentially getting is a high performing, globally distributed content delivery network backed file system. And you're putting your object in the bucket. And this object is backed by this guy, CDN, globally distributed worldwide, and 50 GB of consumption is free for the free tier. And so that is what you're putting together right now as I am waiting for you to give me links like number 1 and like number 2. You can generate a link like number 3 if you have a domain. You need to have a domain for link number 3. Otherwise, you have to use the word Rebecca and you cannot use the word Becky. I hope you get the point I'm saying about Rebecca and Becky. Slide number 3 is like Becky. Line number 2 is like Rebecca.
Yeah, it makes perfect sense.
Cool.
So did you want us to do that now or after the lecture's over?
Go ahead, do it. It takes like 2 seconds, literally. Just create a distribution and hit it. That's all it takes. Like, it's a click of a button, practically. So you already have a bucket. All I would like you to do is create a distribution in CloudFront, like click and click and click and drop down. You have only one bucket to begin with. Click and click. That's it. Few clicks. And you have a CloudFront distribution. And we can while you do that, take 2 minutes to finish it off so you get a clear understanding about CloudFront, creating it, making use of it, distributing it globally, making high performance distributions, caching, making sure that the first guy in Jakarta still hates you because you're still slow, but the second guy is going to be happy. You get this point about first guy hating you, right? Because the thing is very slow because of the cache miss.
How long does it take to synchronize across globally, usually?
So it does not synchronize at all. The idea behind CDN is it will do nothing if there is no usage. So if you do not have a guy in Jakarta and all your traffic is basically from New York and your object is in Seattle, then your New York City users will get first hit from Seattle, which will be a miss, but subsequent will come from Virginia, which is the East region, US East 1, and they will all be super happy.
Yeah, I was talking specifically about when you're viewing your CloudFront distributions on the AWS CloudFront console, it says status, mine says in progress, and there's just a wheel turning.
15 minutes. 15 minutes.
Okay.
Yeah. So basically what it is doing is preparing itself for able to replicate on demand. So if there is nobody from Jakarta, it will never reach Singapore. If there is no visitor from Jakarta at all, I mean that region of the country, of the world, then your object will never go to Singapore. Unless there is this guy in Bangladesh that hits or attempts to access, then it will automatically start and move here. Until that time, it is going to be not going to Singapore. It doesn't automatically go everywhere because that is expensive. You send items to geographically distributed locations only on first access.
So right now there will be no user accessing your objects, right, Nilesh?
You hope.
Yeah. So
yes, you're right.
So what is it doing? What is it doing for 15 minutes? You said it doesn't go to those edges.
Yeah.
If there is no user accessing it, right?
It is the time Amazon takes to prepare itself.
Okay.
It is not actually sending to Singapore because there is no demand.
Okay.
Hey, Nilesh, can you go back up to your Atom page? And so I created number one.
Mm-hmm.
Number two, I've got my CloudFront working right now. It's doing its sync. And then for number three, how are we? I'm still confused about number 6, right? It's okay.
So this is an alias.
Okay. So in order to get this alias, do we have to wait for it to finish syncing, or should it already be CDN dot yada yada yada? I'm confused as where I can go look at the CNAME and all that stuff.
I know. You cannot get a CNAME if you do not have a domain. You need to have a domain name, right? You need to have a domain name. And in my example, here is the domain.
Okay.
So now we also have to set the permissions right, because I've set it up, but I tried to access it and it says access denied. So I have to set permissions on the
origin.
On the origin, right?
Correct. Origin permissions propagate. So if you origins permission read only just for you, nobody else can, then you are not going to allow anybody to access.
Okay. Makes sense.
So would that be in the restrict bucket access? If you go to edit origin, origin settings?
Correct. Open up access so that people can access it. Otherwise, you cannot. People cannot.
Okay.
When I'm trying to change the permissions on my file. The only permissions I have available to me are list, upload/delete.
Mm-hmm.
So I don't think I want to give people upload/delete privileges, do I?
No, you do not. All you want is for everyone to open and download. That's it.
Yeah, I don't have that option though. My options are list, upload/delete, view permissions, or edit permissions.
Correct. So you are looking at bucket level,
Yes.
and
Oh,
I was
there's a
looking
picture.
at object level.
Okay, got ya. Sorry.
No worries. So two different set of permissions. At object level, the permissions are open, download, view, and edit. At a bucket level, the permissions are list. List as in show me the items in the bucket. Upload as in add a new item to the bucket. Delete as in remove an item from the bucket. View permissions as in see what permissions are. Edit permissions as in change the permissions on the bucket. So you don't want these permissions to be given to other people. What you want is at the bucket level, allow everyone to list, and that's it. Similarly, at the item level, you want to at the item level, object level, you want to allow everyone to open and download the object. That's it. And similar concepts of permissions are also available in other clouds, like cloud.google.com. Same thing. Console, storage, console, storage. Where is storage? Cloud, storage, and then there is this bucket that you want to set permissions for. So you can edit bucket permissions, and this is bucket level. You can adjust bucket level permissions of who can access, who can view, and things like that. And also go inside the bucket, and you can adjust the permissions for an item at the item level, edit permissions, and allow people to read and all users read, things like that. And that's the level of granularity available in both services examples we saw in Amazon, in S3, as well as in Google. And so is true with these guys. I just don't like using them for some reason. But yeah, it's the same thing. Let's go play with.
Can you demonstrate again how to put a picture inside that bucket? I'm sorry. I've selected the bucket,
So,
and then under actions.
Are you talking about Amazon Cloud, Google Cloud, which cloud?
Yes, I'm on Amazon Cloud. I've selected the bucket, and under actions, I have create, delete, empty, refresh, or properties.
Right. So you are right here in the bucket name.
Right.
That's what you have, right? So I'm going to delete the item that I have completely. So here we go, item, delete, and say okay, and then I have nothing right now. So right now, this is what you have, pretty much similar to this, right? Now, at this moment, on the bucket name, when you click once, you have to look at the blue button in the upper left corner. It says upload. Okay, do it again. Upper left corner, upload, and then add files. And
I gotcha. No, thank you so much. Yep.
You're welcome.
Once you've created the CloudFront CDN thing, how do you get the link?
So once you get
how do you build the...
right, it's already given to you. So you go to CloudFront, and then you click on the name. It's right there, right here. So on the distribution, when you click on the name, it will give you the domain name. Do you see that?
Yeah, I do, but when I put that into the browser, it doesn't work. So
Okay. So let us understand the origin and check your origin path. And does it map correctly to the bucket you have? Or rather, what I would suggest is go to S3 and identify the bucket that you have selected, and then click on the item, check its properties, make its permissions as available by everybody to open, save, get a link, and then grab that link. And that link is what I would like you to give me. Some similar to this. So once you have that link, it will look like this. It will be something somewhat similar to this. A bucket name followed by object. And so that's the link you will have. Now when you get the CloudFront distribution, you basically grab the CloudFront distribution name from here and go to the distribution and then grab the name from here like that. Put it back in the URL like there, and then hack it and construct the URL back up.
okay.
That should bring it up like that. Access denied.
So Neelish, what I put into the chat, that's the first one, and now I need to create a friendly name. Is that what we're?
Friendly name is a part number 3, which you may not be able to if you do not have a domain.
Well, I do have the domain.
So if you have a domain, then I will illustrate those things that are needed to make the part number 3 work.
Well, you see that in the chat, I've pasted in what I can actually paste that into a URL. I can paste that into a browser, and I bring up my my picture.
Correct. Now that is step number 1. What you have in the link is step number 1.
Okay.
What Michael has in the link is also step number 1. Right? We have to construct a step number 2, which is a CloudFront representation of the same item. You have to put a CloudFront layer on top, which is which is evident from the word CloudFront right there.
Right. I've tried to do that, but it didn't seem to work. Well, let's try it again. Create distribution, get started.
The distribution has to complete, by the way. The distribution has to complete propagation. So this status has to be enabled. So you have to wait for it to happen. This enablement happens after the distribution gets active and ready. It takes about 15 minutes. So by the end of this session, I think you will have it working. If you have created a CloudFront distribution, it should become enabled in the next 10 minutes or so, and you should be able to see it working. If not, we'll do a one-on-one and figure out.
So mine's enabled, but I still can't get to the image.
Okay.
Yeah, the state is enabled, but the status is not deployed, Nilesh.
Mine is enabled and deployed, but the image doesn't. When I try to go to the image, it says it's not available.
Okay.
So do I need to set permissions in CloudFront for this as well?
No, CloudFront permissions are by default. Just copy and replicate. That's the default permission. You have to go and check your origin, and so origin permissions, you have to go and validate that. So this is where you will make sure the permissions for the origin are set correctly, which can be checked in S3.
Right. Did that as well.
Okay. At the bucket level also?
Yes, at the bucket level and at the image level.
Okay. So let us, after this session, let's do a one-on-one and figure out what may be happening. So we'll do that. We have 7 more minutes to make sure that we recap what we just covered, and then we go individually in understanding what may be the case in terms of why certain things is not working the way we want it to work. And let me recap before proceeding any further. So,
Yeah, I'll be on that, dude, because I'm having the same problem.
okay,
Okay.
we'll figure it out. So the concepts we did today, the core concepts. First one is to understand that this separation from pets and cows. It's a very critical, pets and cattle, I should say. Very, very different way of thinking about machines. Not like pets, but like cows. Now, what does it boil down to? Is you keep your content and code and logic and other things that are related, that are unique, you keep them separate to the extent possible, separate from your actual machine, EC2 machine or Google Cloud machine, Google Compute Engine machine, or DigitalOcean machine, or some other machine. Keep them to the extent possible separate. And to enable that, we can do this thing called a object store. You have a bucket, you put an item or a collection of items in the bucket, so you put an object there, and this is a bucket. This is a standardized representation, and the availability of these guys, they claim to be 99.99% available. Now this is called 4 nines, right? 4 nines. 1, 2, 3, 4, 4 nines. Similarly, the claim for durability of data stored in a bucket is, I think, like 11 nines. It's ridiculously high. The durability claim for S3 is 11 nines. That's like crazy, crazy high. Let's see what they claim. S3 durability. Oh, there we are. So there we have this number. There we go. So S3 is designed for how many nines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nines. Wow. Now just imagine what that means in terms of a chance of something getting lost. How low that is. Just to understand that thing. It's a very, very high number to claim on a formal website. Like somebody claiming that they are preparing for disaster. Like literally, they're basically guaranteeing, practically speaking, that you will never lose the data. Almost never. Almost.
Like 1 second a year, if even that, right?
No, it is not. By the way, hey, this is durability. This is not availability. It's not measured by time. It's the probability of loss. It is not measured
This
by
data
time.
is not available. Yeah.
Yeah, it's durability. It's the chance of loss. The chance of data loss is very, 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 very low. I mean, very low. That's what they are claiming, and this is their formal website. And so we have to believe them that they are doing some things to make sure that your data is probably never lost. So you can rely on it, and I do.
Do you know? I'm sorry. Do you know what they may be using on the back end for their storage for the data? Is it like a MongoDB or is it? Do you know? I'm just curious.
So I do not know, but I suspect that
Okay.
they're using something like this. This is called Z file system, which allows you for multiple simultaneous failures. I don't know exactly what they use. They don't tell us, but there are technologies available like the ZFS, which are open source, and this is based on the OpenZFS project, which is a part of your FreeBSD operating system, a Solaris operating system, and a bunch of other operating systems that are derived from the original Sun-based OSS. they have this concept of a ZFS. What this boils down to is that in practice, if you have, say, 6 disks, and they are like RAID Z2. This is a special type of RAID. You can have 2 disks failing at the same time and still continue to access the storage available to you in this pool. And that's the technology in ZFS, where you can have a very, very high level of reliability available to you for durability of data. And I have had a chance where I use this, by the way, in my office, and we have about 8 terabytes of protected storage like this, and I have had 2 disks simultaneously fail, and people are accessing data, reading, writing, everything is going on. I come back and remove the disk, I put a new disk, remove this disk, put a new disk, and it will re-silver. And
performance may be deprecated a little bit, right?
Yeah, a little bit. You don't notice it. And so you're back in business and all the 6 disks come back to life. And that is what is a technology available in the open source. That is what I know for sure. But what I don't know is what AWS actually uses behind under the covers. They don't tell us. But they are claiming a very high level of reliability. And that's a good thing. And same claims you can see from Amazon, from Google, from Microsoft. Very similar claims you can come and have them represent that they are actually durable. When you talk about availability, that availability number is not that high. And that means 99.99% of the time, your item will be available to you. You can access it, you can read it, you can write to it, things like that. It is not 11 nines, it is only 4 nines of availability, but 11 nines of durability. That's a distinction I would like you to make. This is about the guarantee that your data is never going to be lost, almost. Whereas availability is like you will continue to have access to your data almost all the time, except 0.001% of the time in a given period of time. So that's the chance of data becoming.
So that's what the ZFS would be more addressing availability, wouldn't it? Isn't durability something else?
Both. So So let's define these words. Let me define it very simply.
So durability is your data and not losing data, and availability is like losing disk and having everything go down.
So the having access to data for read, for write, that is what availability is. And is my data available to me all the time? Yes or no? Sometimes I have a broken connection. My data is not available to me at that time. But my data is there. I know. It is intact. It is just not available to me right now. And that is the idea behind access to data. And that is about availability. And that number is 99.99%. 4 nines. Whereas durability is not about access. It is about something else. It's the chance of data loss. I will actually lose. So imagine if I have like these many files. There is a chance that one of them will be lost. And that is what this 99.11 nines is all about. It's about durability of data.
So Nilesh, when you talked about losing 2 disks, right? You are assuming near real-time or real-time replication of data. Otherwise, if you lost those 2 disks, if there were files that were created, you would have lost them, right?
So that's where ZFS comes into play, and we'll talk about ZFS at some point. But the idea that you have so many files and only one of them is likely to get lost at some point is a very high level of durability. That's the idea. Now, I'm not comparing ZFS with Amazon S3. They are two different animals. But I'm just saying that they may be something like this. They may have extended this. I don't know. I don't know what they use under the covers. They don't tell us. But I know that ZFS is a good tool that you can put to use, and it is open source. Right here.
Yeah, I think what you might be referring to is live migration. So, you know, when it's going down, it's probably going through, they have something like a live migration.
What are you talking about?
To other disks. I'm not so sure about the ZFS, how that might be.
So ignore it. Ignore it. S3 is not ZFS. S3 is not ZFS. We don't know what they do, what tools and techniques they use under the covers. All we know from what they publish is that their durability is reasonably high. You might lose one file out of those many files. I just assume that the count of number of zeros is okay. Just match it up, 11 nines. And so that's all I am suggesting is that the chance of data loss is extremely low. And you might not have access to your data at some point in time, but that doesn't mean that your data is lost. It just means that you do not have access. Availability is only 4 nines, whereas durability is 11 nines. Now, ZFS is a completely different subject that I suggest that you use and read about it. The simplest way to use ZFS is a project available called FreeNAS, which you can put in your home, in your office if you like. It is open source and it gives you a great solution for your home usage, for your business usage, for connectivity to your files, whatever you have files. You can have Unix, you can have Macintosh, you can have Windows connect to the files that you have over the network using NFS protocol, using AFP protocol, using SMB protocol. And these three types of operating systems can connect to your collection of files that you can put in the FreeNAS box. And this uses ZFS, by the way. And so that is available for you in open source and you can make use of. And that is exactly what we have in our storage. All our files are stored centrally in those 8 disks that I keep talking about. Each one of them is roughly about 2 terabytes. It's an old machine and 2 of them can die at the same time. I don't care. All I need to do is just replace them with a new one. And I'm back in, I continue to be in business. There is no downtime and there is no data loss either. And so that's the level of availability that this solution provides, which is a great solution in open source available to you right here. That's what I'm saying. Now, this is not S3. This is not Google storage. This is your own storage. You can make use of it right away. And it is open source and downloadable from this location. And that's where you will get a file. You click the button and there it comes. Now you have it. And this is what you install and you're in good shape from a storage perspective. That's what most open source projects are actually used to extend, and many companies who are preparing storage as a service solutions in the industry today. For example, this is a company, Nutanix, that focuses on creating storage solutions, and what they are doing is extending open source tool sets. In fact, this company, Amazon, also does the same thing. most of their applications that you see here are derived on some open source product to begin with. Like absolutely every single one of them is an open source product under the covers, beginning with EC2. What are they using? They're using Zen hypervisor. This one. Zen.
Thanks. Interesting. Yeah.
So each and every component that you can think of in Amazon Cloud or in Google Cloud or just about any cloud, including the Microsoft Cloud, there is an open source product under the covers. And I'll illustrate that point to you. Like for EC2, the underlying project is this, Zen. What it does is basically creates virtual machines like this one, like we have created for ourselves. So we're going to shut it down. For example, to illustrate the point being that this virtualization software, which is right here, allows us to create a new machine on demand. You saw me do it the last time, right? Quickly create an XP machine and like that. So this concept is to be able to divide a physical hardware into virtual machines is what this project does, Zen. And that is what Amazon uses to run their EC2 service. This one. The next one is EC2 Container Service, which is another open source project called Docker. And here it is. And that is what they are using under the covers to claim EC2 Container Service. What is under the covers? It is basically Docker. Do we have Docker on our own workstation? You bet. And we have it running, and it is all with you on your workstations. We'll experiment with these at a given time, momentarily, eventually, not today, but eventually. So the thing to remember is most of these services that most of these large companies are giving us are actually open source projects under the covers. Sometimes they tell you what it is, sometimes they don't. Like in case of S3, they don't describe to you what technology they use. All they claim is this. That's all they claim. Like we have highly durable, very, very highly durable and highly available storage. You want to use it? Come on, use it. Very, very low price. The pricing on S3 is ridiculously cheap. You can find out yourself. Where is pricing? S3 pricing. In fact, my monthly bill is like 4 cents, something like that. Here we go. So the pricing is for first terabytes, 3 cents. Something like that. It's ridiculously cheap. So my monthly bill, I can show you my monthly bill. Here we go. Okay, there and here. And my bill for, bills, December and expand. So my bill was $63 basically total, out of which my usage for CloudFront, the bill was 1 cent. For, let's say, storage, S3. How much is my S3 bill? S3, come on. Oops. Is it S3 here?
It looks like a phone bill. I can't.
I know it's a complex bill, right? Yeah, but the bottom line is this is the total amount, and then there is a credit applied. So the credit brings it back to zero. Credit is applied to my account because of somebody said, you know what, you have this examination. You have to take a course and an examination, and it's very difficult. If you pass it, then you will give you $1,000. And I said, okay, forget the course, give me the exam. And I just took the exam. They gave me $1,000 credit. So that's what this thing came from. And so I have a credit applied, and I have been using that money for some time. So that's what it is. So that's why I do not get a bill that shows an amount, because it is all zero. But there is a cost. Like right now, this month, I have spent $43. It's a very, very cheap way of using services. Not much expensive. The same thing.
And how much storage? How big? Would you say 6 terabytes?
No, not that much. But the cloud storage is small. It is.
Oh, okay.
So
I
I
didn't know
don't.
your $43. I thought it was for storage.
No, this is like a complete bill, total bill for
Yeah.
my usage of Amazon Cloud. This is my
Okay.
total bill. So Deepak has a comment. Got to run. Okay, fine, no problem. So go ahead if you want to hang up. I think it is timed out. We are timed out, by the way. Yeah, it's 14 minutes beyond. So
Likewise, I got a foot and a half of snow. I got to unbury myself from here in New York.
ouch, ouch. I'm so sorry, man. So sorry. And there's a blizzard coming here, and that's scary.
Enjoy the balmy weather out there. So take care.
Wow.
Oh, don't rain.
Is it really? Yeah.
Oh
It's
my
pretty
So you
goodness.
got like 28, 29 inches right now?
Where are you?
I said, what do you have, like 28,
Oh,
29
right now,
inches?
looking out my window, we got about a foot and a half, but it's going to snow till midnight here. Right now, it's about 2 o'clock Eastern, so it's going to snow another 10 hours. So,
Wow.
Wow.
I
Oh my
didn't, I didn't,
gosh.
this is about halftime. This is like, I hadn't started snow plowing yet, or, I got a corner lot, about 170 linear feet.
Oh,
And
wow.
I'm going to start now, and it's going to probably come another foot after this. So,
You better go get
Yikes.
some groceries.
oh man, yeah. Well, we got those. I went to Costco yesterday and did the, the Costco run. So
Yeah.
Well, be
Yeah.
safe.
enjoy.
Yeah.
Well, I'll talk to you
You know,
Tuesday.
in Seattle, people use the table salt shaker on the highway, right?
Yes, exactly. We don't get snow here.
Yeah, they use
No,
this.
in Seattle, we don't salt the roads because it's bad for the environment. So we
That's
don't
right,
do that.
right. Occasionally, I've seen like my neighbor using a salt shaker from the.
Oh,
You
you're
get
kidding,
volcanic
really?
ash.
I'm
You get
just.
volcanic ash there, or something like that.
Yeah, we did in 1980 something. Yeah,
Oh, that's that far
it's
back.
been a while though. Yeah,
So
we
now
didn't hit
make
Seattle.
sure
It
you
blew the other
I'm gonna go.
way.
I'm gonna go put my
make sure
snowshoes
you
on.
make sure you knock on wood because we can get snow and ice until February here too.
I know,
Yeah,
I know. So let us meet again on Tuesday at 6 o'clock Pacific.
Thanks,
In
man.
Do
in
we
the meanwhile,
do we want to quickly go through the because again I couldn't get that
yeah, let's do
the
one-on-one, please. So
or
if you
one
have,
on two or something like that.
yeah,
Did
I
Well,
will.
unless I'm not able to access it either. I can list it out, and it tells me where it's at. It just doesn't display the picture.
Yes.
I was going to say
A
that
couple
I
of
was
us
able.
having the same problem.
I was going to say I had the same problem, and I omitted in my after the CDN address, that weird name .cloudfront.net, instead of putting / the name of the bucket, I omitted the bucket name, and then it worked.
Makes sense. Makes sense. So yeah, I think that was Alexander Ramos. Can you please paste your link in Slack chat so that we'll get a clear
Yeah.
idea what you're talking about? Which is basically, see, the idea is like this. So you
Well, right now it's not working because it's resyncing. I made a change. It's in progress. So, but it did work. That link. But the name of my bucket is Ramos Cloud, and I just got rid of it in the path, and it worked.
makes sense.
Okay. So,
It should work. Like in the example I have here, you see my bucket name is not here, right? See that? In the example in line number 4, there is no bucket name because the CloudFront itself is a representation of the bucket.
So whoever just posted, Michael Curry, isn't there a actual? So do
So
you have
sorry,
a path
this-
to like the photo? Do you have a path to, what's the path to the photo? Is it like uploads, whatever? I mean, yeah. So
Oh, I see.
do you have a?
Yeah. That's cool.
So this is Ramos Cloud, and that's coming up nicely.
That works now. Yeah.
Yeah. Now, by the way, who is this person? Is that
That's me.
okay? Awesome.
That was Halloween.
from the
Nice.
1980s.
Yeah.
Yeah, that's my GitHub picture.
Nice. I like the mustache. Yeah, beautiful. Let's look at Michael Curry's link. Here, I would like you to please let me know if you have the bucket picture link complete. Just give it a try, will not work. There needs to be an item in the bucket, like in the example from Michael. I would like to have something after that. What is that is what I would like to know. And Helen has also given us a link. Helen's link is right here with a lot of snow going. And so now, Helen, what I would like you to do is you put your CloudFront and then paste this after that. That should.
Yeah, I did that, and it didn't work. Okay, so I understand what you're saying.
Okay, so let's see if you want to. So somebody's.
I think it's redistributing now, so maybe it'll work after it does that. If after it whatever's. But
makes sense.
That's my.
Cool.
That's my CloudFront thing, but it's just not working. So.
Yep, it will work on. Let's see what. This is some stake. So let's look at some stake now. We have give it a try followed by image. So now we will go to Michael Curry's CloudFront and.
Yeah, I think I know what I did wrong.
Go ahead, describe.
I didn't, like he was saying, I didn't tell it. I gave it the CloudFront name. I didn't give it the rest of it, right? Tell it to go to my give it a try folder.
Okay, good.
That was the part that I was missing. I would assume that all of that was embedded into the CloudFront.net.
Yeah.
That was my wrong assumption. So.
And so this is Helen's CloudFront working. Right there. So we have Helen's CloudFront working correctly.
Did it?
Yes, it did. Right here.
Okay. Okay.
Yeah, that didn't work for some reason. Oh, never mind. God.
Yep. Okay. All right. Thank you very much. I'll talk to you later.
You're welcome. We'll meet again Tuesday.
Oh, actually,
yes, go ahead.
One other question. You said that there were some clients that we should install for Slack and for GoToMeeting.
Yes.
Which are those?
So
which clients are those, and where do we get them?
Slack.com downloads.
Okay.
So we have a Mac, Windows, and Linux client and a phone client.
Yep.
I pasted a link in Slack chat, so you have it.
Okay. And then for GoToMeeting?
For GoToMeeting, the link is in Gmail. I'll give you a link. Hold on. Coming up. So the link for GoToMeeting is here. Copy link in Slack chat as well as in GoToMeeting chat. And that link will take you to this page where you will find a DMG for Mac and MSI for Windows. And you have to click the install MSI button right there. Or for Macintosh, you have to go and identify DMG, which is on the link next to it, like that.
Okay, great. Thank you very much.
Install DMG. So we meet again at Tuesday, which is 26 at 6 o'clock Pacific time. Tuesday 26. In the interim, if you have a question, if you want to do something or need some help, one-on-one chat is available in Slack.
Okay, Neelish, have a good weekend. Thanks a lot.
You too. Enjoy. So Calvin, you're getting an error when I try to SSH permission denied public key, and the reason could be that you do not have your public key in the Amazon console before you launch the machine. So basically, in Amazon, in EC2, in key pair, you have to have the key pair public key in import key pair, and that has to be done first thing.
Right. I've done that. Done it numerous times, actually.
Okay, then let us see what's going on your screen. Here we go. So please share your screen.
Okay. Do you see my screen?
Not yet, but it's coming.
Okay.
Not yet. You have to click some button somewhere apparently to allow.
Yeah, I'm trying to figure out. Let's see. Please.
Let me send you a request again. That will pop up. So I'm making myself a presenter and then changing back to you as a presenter, Cal, and sending you a request to share your screen.
Okay. So I see you're the presenter. Go to me and you've been made the presenter.
Correct.
Okay.
Now you share your desktop.
Okay. So how do I share my desktop? Where do I say share my desktop?
There should be some button somewhere that says that.
I'm looking. Okay.
There we go. Now we can see it. So your key name is called KeyGen, right? I can see that.
Right.
Now I would like to request you to please show us your virtual workstation.
Okay. I'll bring that over right here.
Right. Okay. Now let us.
I can delete this keygen and recreate it. Does that sound good?
Right. You delete the keygen, also delete your machine. You want to go to your dashboard and delete the machine you might have. EC2 dashboard.
Oh, so we want to start all over again.
That's right. A running host you cannot inject a key on. You have to create a machine.
Okay, so yeah, I've got this running here. So you can't change it once you've built the instance, correct?
Correct.
So you build the key pair first, then create the instance?
Bingo. Yes.
Okay, that's my problem. I created the instance, then made the key pair.
Too late.
Okay, I've got it now.
Okay.
So I'll give you a holler if I have more problems then. It's just I didn't realize there was an order.
Yeah, there is. So I understand now. Okay.
Okay. I'll fix that.
Yeah, you can do it. You can basically go to EC2 dashboard. EC2 dashboard up on top left, dashboard, and then terminate your running instance. So click the running instance and kill it. Right click, terminate. Instance state, terminate.
Here we go, terminate, yes. Okay, we'll
And
get
say
rid of that.
yes to it, and say yes to it, and say bye-bye. And that goes away. Now you go to key pairs, and you import your key pair.
There we go.
Import.
Key pair.
And here you can call it IDRSA, whatever you want, keygen, genkey, and then you paste from public key.
Now it gives a just says SSH RSA and then a blank, but I guess that's okay, right?
Yes, it is okay. It is okay. It's not a blank. It's just a roll of the characters.
Okay, so let's go back here. Let's launch an instance. Next. My public IP.
Yeah, by default, it is already enabled, so that's nice.
Okay. Storage, take 8 gig, that's great. Instance, okay, security group. Does it matter?
Yeah, it does. You have to create a new security group or select an existing security group, one of those two. So select an existing one. The launch wizard number 2 is a good one. Or
here.
Even default is also good. Yeah, go ahead, review and launch. And here you want to launch the button and then select your key gen key.
Gen key, acknowledge.
Launch instance. Then you go back to your terminal. Get the IP address. It's coming up.
Yep, that's what we need.
So refresh and it will show you the IP address. So refresh your browser. Control R.
Control R, thank you. An IP address, there you go. Permission denied. Okay, same problem.
Mm-hmm. Okay, so let us understand what may be happening right now. It is saying agent admitted failure to sign using the key. Okay. Give me a second. I want to understand what this error is. It's a different error than what you posted the last time. You did not have this new line this time. Is new. Agent admitted failure to sign using the key. That is a new error that you did not have before. So I want to understand what may be happening.
Is this okay? We are running. Well, still initializing. Could it be that we're not really there yet?
Yeah, so the way to solve this is to type this command. I'm going to paste it in Slack chat.
Okay.
And that is what you should type.
Okay. SSH agent-s. Okay.
You have to copy the whole thing exactly like it is.
Okay. Oh, eval. Okay, gotcha.
Exactly like it is. And then another one. Okay, now run it. Up, twice. Up arrow twice. Enter.
Oh, now I'm in now.
Yeah. So this was a transient error, and it was because your SSH agent was not evaluated. You can read more about it right here.
Okay, will do.
So I pasted you a link as to what is going on, what was the issue, what's the resolution, and you have it now in Slack chat.
Great. Thank you very much. I really appreciate it. I'm not sure I would have gotten there. Okay, so order matters, of course.
Yes.
Get your pair set up first, then create your instance.
Yes.
And don't change it. Just keep reusing your pair. And then if you have problems with your agent being ready, you run this command.
Correct.
Eval.
Eval.
Okay.
Yeah. You're welcome.
Thank you very much for the help.
You're welcome, sir.
Please make sure you record Tuesday's session because I'm on a business trip and I'll have to take a look at it sometime when I get back on Thursday.
I will. Thank you.
Thank you. All right. Bye-bye.
Bye-bye.